Okay, here I am. Let's do the thing. Clap, clap. So, I was thinking about this, and I basically think that since it looks like the name table stuff is mostly correct, although it's not entirely, the reason that the screen is as goofed off sideways as it is, right? So you can see this is clearly offset from where it ought to be, and that's because I'm doing the tile fetches wrong. I need to fetch some stuff early that's not getting fetched early, and so on. So that's going to be step one. And then step two is I suspect that the pixel stuff is wrong, like the pattern table stuff is being fetched wrong, because that would explain why it looks so goofy. And I suspect I probably just didn't read that addressing stuff correctly either. So, hi 8 little bits. Hi Diana. Alright, so here's what we're going to do. First off, if we take a look at this thing here, right? My camera's a bit off. Okay. Let me, how's that? Better? Alright, so it's 8 cycles per tile, 32 tiles per line. But this is unused tile fetch, right? And then this is first 2 tiles on next scan line. That doesn't quite add up right, because that would make 33, right? Because this is tile number 32, and then 33, 34, and you don't use this one. So I don't fully understand that. But whatever, I guess. So what I was saying is, this is not going to be tile equals 0. This is going to be tile equals 0, 1, 2. Right? So we're just going to change kind of how we handle what tile it is overall. Start with 2. Yeah, so none of this is used. Hi, Lila. So can you answer this question for me, Lila, perhaps? So I'm looking at this diagram, right? You fetch a tile every 8 cycles. But it shows you fetching tiles up till 256, which is 32 tiles. And it says this last tile fetch is unused. Okay, reasonable, that's 31. And then we fetch the first 2 tiles of the next scan line over here. But that adds up to 33 tiles, and there's only 32 tiles per... Oh, it's because if you scroll, then it might be different, right? That's why. Because if you scroll, you might render part of tile 0 and part of tile 33. That makes sense. Yeah. What's the progress like now, then? Well, let's show you. I'm able to draw. Well, it's probably broken now because I changed some stuff. But I'm able to draw some things to the screen. This is what I get for getting halfway through fixing it. Okay, so. Right, so I'm doing tiles all wrong currently because I am saying that the first tile fetched is tile 0. And that these 2 tiles I'm not using. So that's all wrong, which is why it was shifted over to one side previously. So this is going to be if tile is 0. Right? Yeah. And this is going to be if tile is 1. We're going to start with 2. It's not clear to me whether I want to bump the scan line early. I probably do because the name table fetch won't work, right? So when it says first tiles on next scan line, I probably need to start bumping the scan line sooner. which means that's fine, but this is not. This should just be scanline. Hi, Alt Overflow. Hope I'm not screwing this up. I probably am, but that's okay. We'll figure it out. I probably should have committed first, though. Actually, let me do that before I screw everything up. Right, okay, so this works. Git status, git add, search star.rs, git add tests, star.rs. Is there anything else missing? Nope. Draws a screwy Donkey Kong. Okay, and then we can control R back to our previous state. Still working on my SNES emulator in Rust, going pretty so far. What's going about it? Is it just harder than you thought, or? Damn, someone who's smart enough to commit before breaking everything. Yeah, well, I specifically did not do that earlier, so it's a less than hard one. Okay, so previously I was saying that this tile 32, which if this is 0, 1, and then there's 32 here, 2, 31, so this is going to be, what, 33, I guess? This doesn't seem right. It's just that Rust has too many things going on. Yeah, okay. Is it your first major project in Rust? I can see where that would happen. It's your second, okay. When do we bump tile? Tile 40. Otherwise, we just bump it once. This doesn't seem like it was right before. Confused. Anyway, 33, I guess, right? So 0, 1, unused, unused. The first is my NES emulator, which I reverted back to Golang after a lot of frustration with the borrow checker. That's interesting. I haven't really run into much borrow checker troubles, except for in one place where I said, hey, I'm going to do this wrong, and I bet the borrow checker will yell at me, and then it did. Gosh, this is so goofy. So if we're on tile 33, we're going to delay through h blank, which means the next tile that we fetch is going to be 0. But then for the unused name table fetches, we don't really have something for that. So when does that happen? How do we get there? Oh, okay, so that's this check right here is what's happening, right? Because that's ugh. This is such a pain in the butt. Alright, so let's start at the top, shall we? The first thing we do is the no-op frame, which is this cycle right here. We should probably start on line 261. for one thing, but we'll do that later. So if we're on a rendering or pre-rendering scan line, then we're going to start with tile number 2, which is at address 1. Let me pull up my notes here. Tile 2, address 1, or cycle 1. And then otherwise we just skip, and that's fine, hopefully. Oh, well, that's 261 and that's 241. Okay, so that's fine. So Alt Overflow, what were your specific frustrations? Like, where was it giving you grief? Just like general coding stuff, or was it an architectural issue that it was pushing back against? Okay, so then you go to fetch NT, and if you're on the pre-render scan line and you're fetching tile 2, then you clear all the junk, which makes sense. This should all be right. If tile 0, so the intention here, this is actually supposed to be this guy, which is at cycle 337, right? So tile -2 is cycle 337. Tile -1, cycle 339. I think it was just the bad programming I did. I gave Rust a second chance, and so far it's going much better. That's good. Also, if it's been a while since like between the two, Rust landed non-lexical lifetimes semi-recently, and that has resolved an enormous amount of headache. Okay, so this is actually if it's -2, and then otherwise if it's -1. And then you're going to push it with tile 2. So that's reasonable. Otherwise, we're just going to fetch the AT, right? And then the AT works. It doesn't do anything interesting. It just transfers onwards to background low. The background low fetch does its thing and then passes on to background high. The background high just passes directly to ink horizontal. So ink horizontal is going to be the one that we're looking at. So if this is tile 2, tile 3 is cycle 9. Tile N is going to be N-2 times 8 plus 1 for N is less than 33, I guess. And so if you do tile 33 minus 2 times 8 plus 1, that is 249 is the beginning of it. So that's correct. Okay. I still wouldn't call it my favorite language, though. Yeah, you know, I like a lot of things about Rust, but yeah, I'm not going to argue with you on that one. If title is equal to 3, blah, 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 so that works. Otherwise, just increment by 1. So we need to add another case here, which says that, right, and then we're starting with tile 0. And we do the increment horizontal, and so what we need to do is, if it's 0 and then 1, we're going to need to push -2. Else, if tile is equal to 1, fetch name table -2, right? And then in fetch name table, okay, yeah, so that should fix that. What what I want to make sure that I do is print the scan lines in both background and pixel mode to make sure that they stay synchronized. What am I looking at here? There we go. Make sure that the scan lines occur at the same time. Cannot apply unary operator negative. Unsigned values cannot be negated. Okay, fine. Be that way. Tile is currently a U16, even though it only goes up to 32. I don't know why that is. So let's make it an I8. And then it's going to not work, obviously. Oh, I think it... I did not change this into here to an I8. And then expected U16 found I8. Oh, that's because I pushed, I specifically annotated this guy. That's a sprite one, which is fine. This becomes an I8. Literal out of range for I8. Sure, because it's not actually used, right? That's the only thing. Okay, let's see if this works. Made a fair number of changes all at once, but oh god, I'm printing way too many things. I gotta stop doing that. Yeah, those don't synchronize at all, do they? Also, BG no op scan line 0 is all that's happening. So I'm not changing the scan line at the right time, obviously. We want scan line actually to change after H blank, not during the no opery. Although, in this case, because there is no H blank on these lines, this is actually fine. Because none of that's going to matter. Except maybe set V blank. I don't think it does, though. Yeah, no, it doesn't. So, that's fine. That can still increment. This one is from sprites and not interesting. Okay, so I'm just never incrementing it now. Cool. Cool, cool, cool. In that case, we want to increment it when? We want to increment it after H blank, which means it's going to be in Inkwise. So once we've delayed through H blank, scan line +1. Mod 262. And then when we construct it, we want to start with, instead of scan line 0, we want to start at 261. And instead of tile 0, we want to start at tile 2. Still not going to line up, though. Yeah, doesn't line up. Close. Yeah, so let's just go ahead and check out a couple. And also stop printing this bit. Oh, yeah, okay. Mabi and scan line is not equal to 261. We also need to be printing something somewhere so that we can actually see if it lines up and by how much it does not. Yeah, obviously not lining up. BG no op is happening 1, 2, 3, 4, 5, 6, 7, 8 cycles too soon. Probably has to do with this. Don't really know why it would have to do with this. I bet if I do this, it will be correct. Air quotes. But it's still wrong. So I have to figure out why. Yeah, so that makes it correct, but it isn't correct because you should never be fetching a tile 34, right? Because this is 2, 3, 4. If you take 33 minus 2 times 8 plus 1, that's the right tile index. 4, let's start with, so 4 minus 2 times 8 plus 1 gives you 17. 2, 3, 4. So why are you giving me grief here, buddy? Something is not happening that I'm expecting to happen, or is happening that I'm not expecting to happen, and it's giving me one extra tile somehow. So let me just print out in fetch name table. We will print out the tile, which we were already doing earlier. Should make this just 1 so that we have less to comb through. And then let's see what happens. Choo 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 kerplunk. Alright, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah blah blah. 33, that is PPU cycle 249. So we are doing that wrong, right? So I was right that the 34 should be a 33. And then I guess we're delaying to 321, which is correct. That's the next negative table fetch, which is byte 1. And then 337 and 339 are these two, and then we loop back around. So this is almost right. It's just that we were somehow screwy there. Which I guess this is supposed to be like that, maybe? I don't know how I got these numbers. But I'll just add more weighting. And then it should be fine. Show me the money. Show me the meaning of being lonely. 254. Yep. So that's right. This is at 321, 329, 337, 339, and then this last one for tile 33 is at 249. Okay, we're good. Get rid of the panic. Thanks for that song stuck in my mind now. Which song would that be, Lila? Show me the meaning of being lonely. Is that in sync or who's that? Voice to Men? One of those guys, anyway. That looks a little better. Backstreet Boys. That looks a little bit better. Hard to say if it's entirely centered. It looks a little bit not quite entirely centered, but it's much closer. So that's good. I need to walk in. Tell me why I can't be there where you are. I like that song. I like Backstreet Boys. There's no shame. Okay, so now what? Alright, so that's better. It might be slightly wrong still, but it's better. I've been to a concert once here in Germany ages ago. That's cool. What do you think, Lila? Does that look good? It looks a lot better, certainly. Shift it over. Not quite as gonky. Not a word, but whatever. So now I got to figure out why all the tiles are being drawn wrong. And my sort of assumption is that the reason that that would be the case is because the palette data is wrong. Either in how I'm accessing it or like what's stored in memory. Probably the former. So the palette index is set based on the attribute latches, and then the pixel address I calculate this way. That seems right. Fetch BG low. This is what I think must be wrong somehow. So this is background base plus ppu.nametable byte plus scanline. Yeah, I didn't really mean palette. I meant this bit, the actual data. The chur-rom stuff, the pattern table. So how does a pattern table look? The pattern table is an area of memory connected to the PPU, blah, 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 blah. Each tile is 16 bytes made of 2 planes. The first plane controls bit 0 of the color, the second plane controls bit 1. Any pixel whose color is 0 is background or transparent, represented by the dot in the following diagram. The pattern table is divided into two 256 tile sections, left and right. The nicknames come from, yeah, okay, whatever. They are displayed as side by side, blah, 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 each representing 16 by 16 tiles from the pattern table. PPU addresses within the pattern tables can be decoded as follows. Find Y offset, the row number within a tile. So that's the scanline mod 8. Bit plane, so that's the plus 8. tile column, tile row, half, and then 0. So this is the get background base, but it's the column and the row that I must be doing wrong here. The tile column is gonna be, the tile column is the thing I'm calling tile. But wait, how does the name table come into this? I thought you fetched this based on the name table byte. Is that not true? It is. So the tile column and tile row, like what is this junk? I never got this part of NESDev. But anyway, okay, forget about that then. The name table byte obviously needs to be multiplied by something, probably 8, because you want to walk, yeah. So probably times 8, or 16. Why would it be 16? Oh, because you need to jump over both halves, both bit planes. Yeah, okay, so that makes sense. Bit planes. What a dumb way to explain this. Somehow that doesn't look better. I gotta turn off printing this cycle. It takes way too long to draw. That's not really better, so also we're just gonna take that out. Send me the first 4 bytes to future ROM. I so doubt that it's the future ROM's fault, but sure, fine. I want to see what happens during this thing. Whoa! Oh, it looks so good. Hey, that's very recognizably Donkey Kong. It's zooming all over and around the world, but it's very recognizably Donkey Kong. This is super definitely making progress. Okay, so you want the chur RAM at what point? Does the chur RAM really not change that? Or change that infrequently? Just the first 4 bytes. Not in Donkey Kong. Okay. I think the wine is helping you make progress. Yeah, we've transitioned from from coffee stream to wine stream. Oh, I forgot to panic. Oh, no, I didn't. It's right there. Never mind. I gotta stop picking at my braces. They're so annoying. Okay, so I waited too long. I think the word you were looking for was probably little in that case. Too little content. 0377. damn it. It's not what I'm doing. Okay, there we go. Comment this out. So what I wanted to do was to basically print the address that I'm accessing. Also, I can turn off the no-op stuff because it's working again. You got 004D77. That's close. Okay, yeah, I mean, obviously a lot of this is wrong still. Would you look at that? So, how am I getting 1247 for all of these tiles? Also, I bet I didn't change my high byte access. Nope, Super did not do that. What address was what? Okay, that's more closer. I'm not sure why it says one-player game with all the letters reversed, but that's definitely closer. Color is still super wrong, and it still does this thing, whatever the hell this is. But that's definite improvement. Okay, so this is what doesn't... I mean, I guess it could if the name table is the same. The shift is 7 minus val. What shift? To reverse the characters. What? What am I supposed to be shifting? The read on the tile data. I'm not shifting anything. Oh, are you talking about in this point here? I'm shifting to the right bicycle mod 8 because I don't have whatchamacallit? I don't actually have scrolls. That makes sense to me. And these are all squares, which is why you couldn't tell. Okay, that's better. It still isn't right, but it's better. There's like extra bits hanging off the sides here. And it still does that. So we'll have to figure out why. eventually. I'm not sure we're actually skipping the odd-even cycle right now, so that probably has something to do with it. Off by 1 somewhere. Yeah, probably. Question is where. So I want to see this, right? So just taking one. Oh, that's not. Wait, what the hell? Doesn't make any sense. I thought the name table byte is supposed to be a byte. Oh, I put it in the wrong spot. Okay. That makes me feel better. I was going to be very upset if the name table byte was not a byte. Okay, so name table 24. I'm just going to work through this manually real quick and make sure that it comes up where one would expect it to be. So the base address is probably 1000, right? Or 0. Right, and so in this case it's 1000. And then you have 24 times 16 plus scan line is 157 mod 8 gives you 5. Okay, so 5 plus hex 24 times decimal 16 gives you hex 245, which does match this. And that seems basically correct. All right, so yeah, it probably is something to do with this shifting. I haven't actually looked into how scrolling, like FineX stuff, works at all. So I guess I can just tweak it until it works. It's sort of upsetting, but a lot about this project is upsetting at this point. Nope, that made it worse. Upsetting why? Because there's no like pedagogical reason for it. I'm just like playing with it. Okay, that looks much better. It still shouldn't be red, so there's that. And then it is going to freak out in a second here. Yeah, attribute table, obviously. Attribute table is what gives you the color, basically, right? So base plus name table byte, I think, is correct because, yeah, attribute table. It's base plus name table byte because each byte controls. The freaking out of the screen after a while is really weird, though. Yeah, it is. But I'm sure I'll figure it out. I bet it has something to do with when my NMIs are firing. Or something like that. But okay, let's get the colors right first. So each byte controls the palette of a 32 by 32 pixel part of the name table and is divided into 4 2-bit areas. And it's only a 64-byte array. So probably I am doing this not entirely correctly, because the address here probably should be name table byte divided by 4, right? Yep. So I bet that helps. Probably reading the bottom of the next name table instead of the attribute table. All that did was make it dull. It's still all red. It's supposed to be like a blue color, right? It's weird that Donkey Kong is on the background layer. Anyway. DK blue, menu white. Okay. I thought that the DK Donkey Kong part was supposed to be blue. Anyway, unless that's what you meant. Which I suppose it could easily be. So Donkey Kong blue, menu yellow, trademark text white. Yep. That's what I remember. Aren't like some of the letters like different colors too, or did I hallucinate that? Hey, what are you doing? Welcome. This is the day 14 out of 14 of my 2-week Nintendo emulator challenge. I'm trying to emulate the original Nintendo, such that it is capable of running Super Mario Bros. 3. Currently, I'm trying to get Donkey Kong working. It is getting there. Slowly, slowly, slowly. You can see now that it is intended to be Donkey Kong, which is good. Progress. Okay, we don't actually care about the BG low stuff anymore. That's correct, so we'll get rid of that. But you'll be able to see in a couple seconds here that it is recognizably Donkey Kong, at least until he goes insane. So Donkey Kong, all the colors are wrong, but it is displaying the correct tiles now, so that's good, progress. And then if we wait a minute, it will go into the demo. Maybe a while, because it's printing a bunch of stuff. There you go, demo mode, looks great. Everything's wonderful. Oh no, it exploded. You have some kind of ROM and you are trying to interpret it. Yeah, basically. It's pretty much how that works. Okay, I'm going to panic at the end of the first frame, I think, would be a good place. Yeah, so basically, I have the ROM, and it's in a format called INES. So I parse the header of the INES file, load the data into an array, basically, that represents the memory, and then I write an object which represents the CPU and sort of read in the instruction at the program counter address, interpret it, act on my CPU structure in the way that is, that operation defines, and then just kind of go from there. Fortunately, other people have already done all the hard work of documenting stuff for me, so I don't have to. Looking pretty good there so far. Thank you, Silverblaze. It's definitely looking better than it was. Still haven't quite figured out what's going on with the colors, which is my next thing, and then I'll try to figure out why it freaks out all the time, which I think I basically know the answer to that one, but... Okay, so there's basically two addresses that are getting accessed. It's C9 and C0. But all of the latches end up with 0. So for starters, that's wrong, because there's supposed to be at least 3 colors, right? Although I guess it could be the same attribute table. Okay. You know what? I should be... just printing all the information. You know what? Maybe I should wait a couple cycles. Because it might not be... I don't know what I'm trying to say anymore. I've lost total track of it. It might not be changed yet, I guess, is what I'm trying to say. Does the rest have a sleep? It must. Standard thread sleep. Duration in... seconds? Duration in duration. Thanks, friend. Seconds and nanoseconds. Okay. Do. Standard thread sleep. Standard time duration mu 50. And then panic. That way I can check to make sure that it is actually rendering before it dies and that I'm looking at relevant data. Guess what? It's not. Or, well, I guess that doesn't actually count. So let's move it up to the top here, shall we? Except it can't be that either. Whatever. I'll just run it for a few seconds and hit Control-C and then look at the recent stuff. Here is Donkey Kong. Die. Alright. Mostly 23C9. Sometimes 23C0. Always loaded as 0. Which doesn't seem right. So, oh, there's one that's not. There we go. Loaded as 170. That gives attribute table of 2. Scan line 195, tile 5. That seems kind of reasonable. I don't think we ever see... Do any of these look like they're a different color to you? Because they don't really to me. Maybe I should... I know what I should do. Hang on. Fetch AT. Yeah, they don't to me either. So here's what we're going to do. We're going to do if loaded is not equal to 0. Then we'll print all this information. And that way we should only see the ones that are relevant. It is exactly one tile that is non-zero. Which doesn't seem right. So let's see if it is filled wrong. Why don't we just dump it? See what it looks like. Oops. Zero x 23C0 to 0x 2400. Everyone, thank you for stopping by. I really appreciate that. Okay, that looks like 3 colors to me. Don't you think? And if you look at 55 in hex, that is 0101. And if you look at AA, that is 1010. So that seems right, but we're not actually accessing those. And when we are accessing them, we may be interpreting them incorrectly. So that should be the AA one. Yep. And we got AT of 2, which is correct for all of those shift values. So that's good. But it feels like maybe this part's wrong. Attribute tables, there they are. Each attribute table, starting at 23C0, etc., is arranged as an 8x8 byte array. Uh-huh. These pictures suck, man. Alright. I mean, yeah. That's how memory works. Each byte controls the palette of a 32 by 32 pixel, or 4 by 4 tile, part of the name table, and is divided into 4 2-bit areas. Each area covers 16 by 16 pixels, or 2 by 2 tiles, the size of a question mark block in Super Mario Bros. So, yeah, that seems like it ought to be right. The attribute table is just You just add the name table byte to get the index, right? Are you sure you're supposed to add the name table and not the 32 by 32 pixel or 4 by 4 tile part of the name table? Are you sure you're supposed to add the name table byte and not the tile index? For the attribute table, yeah. I guess it would have to be because there's 32 tiles in a row. And it's a 64 byte array. Name table byte is only for tile selection. Okay, let's try that, shall we? Tile. It's 4 by 4 tiles. That doesn't feel like it's going to be right. Fetch NT. So how did this work? This was base plus tile plus scan line divided by 8 times 32. This would be base plus tile divided by 4 plus scan line divided by 8 would give you the Y tile index times 32, which is supposed to indicate because 8 times 4 is 32 tiles. And then this other way, it seems like the end of the attribute table would not be used if it's really 64 bytes, but basically scan line divided by 8 gives you the tile height thingy times however many tiles there are, but then divide by 4 because there's 4 tiles per byte. So 32 divided by 4 is 8, which is what I thought, which means we can just get rid of this entirely and just add the scan line. See if that helps. Whoa! I forgot I was panicking, and it caused me to panic. Alright, let's try that again. Come on, buddy. Happy colors. Give me happy colors. Okay. I got different colors. Does that look any better? All that happened is that the top of Donkey became bright red and added like a weird diagonal. Oh boy. You select the attribute table value through an index 0 to 63 now, right? I mean, I fucking hope so. Who knows? Let's get rid of this. Let's panic on the first time we render something. Explodes. Okay, obviously not, because it's running right the hell off the end of the pattern table. Cool, 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 cool. Cool, 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 cool. Alright, let's just do that, and then it'll die even sooner. Get rid of this. The very first thing! So I obviously did something wrong. What's going on here? Right? Okay. So, oh, this is the name table, not the attribute table. Okay, so the address is tile, which is 2, divided by 4, which is 0, plus scanline, which is 261. Okay, fair, fine. Am I even supposed to be fetching an attribute table? Yeah, probably. Where'd my NTSC thing go? There you go. So you should actually be looking at... So all of this junk is just not used, right? So we're going to say if scanline is less than 261, then we'll actually do the stuff. Or no, let's not do that. Let's effective scanline equals scan if scanline is equal to 26 or is equal to scanline plus 1, right? I mean, maybe not. Who the hell knows, right? Okay. Yeah, if it's 261, then it's never going to get used, so we just won't. If scanline is greater than 240, just ignore it. Go on to the next thing. What? What? I did it wrong. Reverse the comparison. Okay, so we do eventually screw up again on tile 32 of scanline 56. 32 divided by 4 to 8, which makes sense. Obviously, this is never going to work. Why did I think this was going to work? Oh my god, this is so stupid and irritating and dumb. The index into the attribute table. Tile index divided by 4 goes this way. You want to add the scan line divided by 8 will give you the tile index. Is that all you need? Probably not, because you want to get the same hit on the attribute table for the first 4 bytes or whatever. The first 4 tiles, which is 32 pixels, so you want to do scanline divided by 32. That should be better. Every time I change it, it just gets less colorful. Like just a darker and darker and darker red. Times 8, yes. Which becomes divided by 4. And if we have 32 divided by 4 is 8, and we have 240 divided by 4 is 60, plus 8, that's still too big. "32 Y pixels moves you down 1 row. Each row is 8 bytes long." "240 by 32 is 7, plus 8. Yeah, so that should be right, actually. So what happens? "224 divided by 4 gives you 56. I think the problem here is tiles 32 and 33, because they go off the end. So confused. Yep. The problem is that it's not actually 32 tiles across the screen. So an 8-byte across table doesn't make sense because there's 33 tiles. Except that there aren't 33 tiles. Not really. So what do? It maps to the name table. That's what I was doing earlier. And then Lila told me it was wrong. And it also super definitely wasn't working. You mean like this, right? Is that what you're saying? The base address plus the name table byte divided by 4 because there's 4 tiles. Hi, could you draw individual pixels in the NES? Yes. Sort of. No, not really, actually. It's a tile-based thing. You don't think so? Well, what do you think? There we go. It's not mapped to the name table byte, but to the address? The address of what? I mean, I guess I could just calculate the name table offset and then divide by 4. How big is the name table? The name table is a kilobyte. This thing's only 64 bytes, so that's not enough. 1024 divided by 4, 256. So divide by 32. 3C plus R divided by 32 times 8 plus column divided by 32 plus current name table start address. Right, okay. So divide by 32 times 8 is the same as divide by 4. I think R is your tile, right? Oh, so you're just saying I have, it's just rotated, right? This should be scan line, and then this should be tile. Divide by 32 doesn't make any sense in that context. Hang on. Column is your pixel. So, okay. So to get to, so your pixel is equal to my tile, or your pixel divided by 32 is equal to my tile. And then R is your scan line, divided by 4. Well, okay, so scan line divided by 32, which is the tile thingy, times 8, because there's 8 tiles. That really doesn't seem right to me, but okay, whatever. If it works, who cares? Okay, so scan line divided by 4 plus tile. And then I need to cast a bunch of those things to U16, so it's not going to build as U16, as U16. Incorrect close delimiter for some reason. Where are you yelling at me? Oh, it's here, because I don't do that. How did Elite was able to draw lines in the NES? I'm not sure what you mean, to be perfectly honest. That doesn't seem right, Lila. I guess the tile has to be less than 32. Scan line 240 divided by 8 gives you 30, plus the tile can be up to 31, gives you 61. So that should fit. Except that's not what I'm doing. I'm dividing by some other number. Am I dividing by 4? So 240 divided by 4 is like automatically too big. So it's 60. So R is your row of tiles then, Lila? Like, what is R? R can't be the scan line because that just straight up will not work. Row of pixels 0 to 959. What? There aren't, that's too many pixels. All name tables. What are you talking about? That doesn't make any fucking sense, buddy. I'm gonna just divide tile by 4 and see if that helps, except I know it doesn't because I've tried that before. But now I'm restricting the range of the tiles, so I guess maybe it'll be okay. Nope. Oh, it probably needs to be less than. So 239 divided by 4 plus 7. Still too many. Doesn't work. This is a real pain in the ass. Doesn't seem like it should be this hard. Each byte controls the palette of a 32 by 32 pixel or 4 by 4 tile, part of the name table. So basically, why does it say part of the name table? Why does everybody have to think about this so wrong? Anyway, alright, whatever, okay. Focus up, quit bitching. Is this Rust? Wouldn't C be better for performance? No. Yes and no, respectively. Rust is basically just as fast as C. I mean, talking about the speed of a language is not a super well-defined thing to do anyway. But because Rust doesn't require any kind of runtime, and you're able to do all of the things that you can do in C in Rust, as long as you're willing to jump through certain hoops, because a lot of the things you do in C are wildly unsafe. There's no reason that C can't be just as good as, or that Rust can't be just as good as C, or vice versa when it comes to performance. Also, the NES runs at like a megahertz, so performance is not a huge concern. All right. So tile 0, scan line. All right, for tile 0, 0, we get 0. Tile 1, 0, we get 0. Tile 0, 1, we get 0. Tile 1, 1, we get 0. All right. Tile 2, 0, we get 1. Tile 0, 2, we get 9. So if, assuming that this is right, which this kind of makes it look like it's right, you get tile Y is scan line divided by 8. And then you get tile Y offset is tile Y divided by 2 times 8. And then tile X is just tile, and tile X offset is tile X divided by 2. So, tile divided by 2. Or is that even right, actually, because it's supposed to be a 4, not a 2. So this is actually not quite correct. It's supposed to be 4 by 4. which seems really large, but okay. So this would be, instead of tile 2, it would be tile 4. Instead of tile 0, 2, it would be tile 0, 4, but it would still be 9. Or 9, 8. It would be 8. And so this needs to be divided by 4, and then this also needs to be divided by 4. Okay. So we have tile divided by 4. And then we have scanline divided by 4 times 8. Which really, oops, times 8. Which really should just be times 2, except that it is going to take out some of the unnecessary bits by doing the divide and then the multiply. And yet, alright, so we are on scan line 32. Divide by 4, you get 8. Times 8 is 64. So yeah, I guess that's fair. It's not... Yeah, so tile Y offset is scan line divided by 8. It's tile Y divided by 4. So scan line divided by 8 divided by 4 is what I was doing wrong. Okay. These are now slightly different colors, which is at least sort of correct, and we're not accessing off the end of our palette table. That's much better. Is this Virtual Boy? It is not. It just looks like Virtual Boy because everything is being drawn as red, and I still don't totally know why. I don't think I'm doing this part quite correctly. Because if we're on scan line, we probably want, if scan line mod 32 is less than 16, since it is 32s. Each area covers 2 by 2 tiles, right? So this is going to be tile mod 4. Is less than 2. That doesn't really seem to have changed much. But we are getting 0, 1, and 2 scrolling by. So I think it's trying to be 3 different colors. Okay, so now it's probably the drawing parts that are wrong, right? Because we've got what we think are the right attribute tables. So it's probably pixel address that's wrong. Yeah, now you can see 2 different tints of red. Exactly. Making progress. So now we want to look at the palette stuff, which is in here. Palette attribute, multiplexer, pixel. No, I don't think this is what we want either. Attribute table. Tiles mirroring scrolling. Yes, I am simulating timing. It should, in theory, be cycle accurate. That is my goal anyway. It mostly seems to be correct so far. Okay, so the palette for the background runs from VRAM 3F00 to 3FOF. The palette for the sprites runs, yeah, no one cares. Each color takes up 1 byte. 3F is the background color, which is anytime your background index is 0. And then each 16 by 16 pixel area of the background can use the backdrop color and the 3 colors from one of the 4 background palettes. Palette index is getting set from the attribute latch. Palette index as U16 times 4. So if it's 0, we should get that. Do 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 do. Maybe we should only display this if BG index is not equal to 0 or palette index is not equal to 0. Then print this. We'll see if it is ever true. Obviously it is in several places, so let's take a look at some stuff. Hang on, I thought we were seeing more. Oh, well, there's palette index 1. But how come our pixel address is being the same? Oh, it's because background index is 0. So let's only display when background index is not 0 and make sure that that ever happens, because it should. Go. Okay, good. It does, occasionally. That's good. Should probably remove a bunch of these extra prints. Background index 1, palette index 2. Where's background index 1, palette index, anything else? Okay, so that's 61133 or 61633, and then the other one was 61637. .3F05 for 1, 1. Yup, that seems sensible. Alright, everybody. I need to step away for just a moment. I'll be back in probably about 3 to 5 minutes. I'll be right back. I have returned. Okay. Hello, Useless Pony. Hello, Danny Fritz. Thank you for stopping by. Hi, Lila. Thank you for sticking around. So, the problem now... Hi, Diana. Thank you also for sticking around. So, the problem now is that we appear to have correct palettes and correct attributes, but still incorrect colors. Cool. So... Palette 2, background index 1. These numbers seem correct. So maybe the palettes are wrong? That would be kind of weird. I don't really expect that the palettes would be wrong, but I'm not sure how to figure out what the palettes are supposed to be, I guess, but I'm starting to wonder if I have like a row column transposition somewhere. That seems like a completely believable form of bug at this point in time. Alright, so what do we got here? Pixel index 30, pixel color ECEEEC. Where's something that's other than 1 and 2? Doo-doo-doo. Okay, here's 1 and 1. D4, 88, 20. These don't really seem like all that red of colors, do they? I wonder if I'm just drawing them wrong at this point. DC 8820 and ECEEEC. Is there a frame buffer to look at? Yeah, totally. It looks like this. Maybe it's set to a different drawing mode. You mean like that it thinks it's a different pixel format? Yeah, I think that could easily be true. Let me, though, I want to type in some of these colors. Probably not from the spaz mode. So let's just let it run for a second. I want to type a couple of these colors into a what does this color look like webpage, because I feel like that would be helpful to know for sure. RGBA renderer. So that should be like a white color, which it super is not. And then if we scroll up some, get this one. That seems to be some sort of orangey color. Do they all have 0 alpha? That's the intent. It doesn't appear to be what's actually happening. I mean, maybe it is. I don't know. I don't know what these client formats are supposed to mean. Like, I can make it U8, 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 U8. But there's no, like... I have not been able to find any documentation for these. Oh, hello. How's that look? Better? Not right, but better. least I don't think it's right. Lila? The only part I actually recognize is the in-game part. So hopefully when it starts going into the demo, I'll be able to tell better. Yeah, I've got more color variation going on, that's for sure. Note that none of these colors are orange. I'm printing too much stuff. It takes a very long time to go into the demo mode. Hey, nice. What was the problem? Well, a problem appears to have been a pixel mode. But this still doesn't look totally correct. Looks like I'm missing red, only blue and green. Yeah, I think this is probably still wrong. I wish I knew Glium client format. I mean, like, these aren't useful things. It's just U8, 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 U8. I guess I'm picking an OpenGL format. Are those like things that people know about? OpenGL pixel formats. Like, this doesn't help me. I don't understand. And it's also not, doesn't even show up in the documentation anywhere. Like, what the hell? Can map OpenGL format to Glium. Someone please explain to me how this stupid thing works. Buffers. I think Glium expects a level of OpenGL proficiency. Well, like, I know some stuff about OpenGL. It's been a while, admittedly. But what, like, all it tells you is the size. It's not telling you the format anywhere. Texture as surface draw. Uniforms and stuff. Like, I'm not even getting to that point. Ugh. Let's see if support.rs specifies a format someplace that I just straight up missed. I don't think it does. Spoiler alert, it doesn't. So far as I can tell. It does clear color sRGB. Prepare renderer. Which I guess is a Winit platform call. And then in main, I don't think I do anything like that. I do, like, I register the textures here, but there's nothing about what the actual format is, just the U8, 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 U8 stuff. I guess I could just shuffle bits around until it looks right. I hate doing that. So it looked like I was missing red with only blue and green. So what happens if I move the alpha to the beginning so that it's ARGB instead of ARGB is a standard. So is RGBA. Just saying. ABGR? Is that a thing? That's one I've not heard of. I've seen that before. Okay, I believe you. We're just gonna go ahead and take this off. Move them here. Paste them in. Run it again. There are texture formats for everything. Exactly, which is why your OpenGL wrapper should let you specify what format that thing is in. Hey, look, it exploded. I don't know why I have such an assertion. Oh, yeah, because I was making sure that it was loading things correctly, but now I changed it, so okay, let's see what happens now. Everything's invisible! This, to me, suggests that everything has non-zero alpha. My expectation is zero alpha is invisible. Really? My expectation is the opposite of that. My expectation is that alpha is a transparency channel and 255 alpha is invisible. But that's possible. Okay, I cannot be reading Gleam source code at this point in my life. Like, there's just no way. I sound like I'm in a good mood. Sarcasm? Can't tell. I guess I'm in an okay mood. That says RGBA 8, right? Yeah, and that says RGBA 8. So how am I doing this thing? Which is the NTSC to RGB thing, I guess. I'm loading the first thing into the highest bit. So the first thing should be red. Right? Colors are stored in RGBA format. It only does what the shader wants it to do. Blah, 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 blah. Blah, 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 blah. Everything is such a pain in the butt. So, if we bring these back, it looked like R was always 0. And the concern here is that this is just transparent. So, okay, why not? Let's try it. Who cares, man? It can be whatever it wants to be. I guess I could probably drop the, What? Oh. Yeah, okay. And before I have to revert all color changes. But it was wrong! Oh, yeah, I know. How's that look? That looks correct. Thank you, Danny Fritz. You were absolutely correct. It was that alpha was 0 and it should have been 255. That's awesome. Alright, let me delete a bunch of the stuff that's printing literally every pixel. Attributes are wrong. Hi, Sai. Hi, Solarak. No, Solarak's been here. What do you mean attributes are wrong? The logo should be blue and the middle text should be orange. Yeah, it's probably just in the wrong pixel format still, since I still can't figure out how to like tell it. But yeah, so these just are switched. Yeah, that probably just means that red is backwards. Okay then. Hooray! So I just got DK working. No, not even that far. It freaks out as soon as it starts running the demo for some reason. I think it's something to do with NMI timing. I have some theories, but anyway, trying to get the colors right. Yeah, I'm almost certainly not going to finish the challenge today. But that's okay. I had fun doing it. So, right, I was looking at this. I really wish it was more obvious. 0, 1, 2, 3, 5, 6. Okay, so yeah, that is our GB is the expectation. And currently it looked like we had R and B mixed up, right? That's believable. You know what? Actually, hang on. Here's what I'm going to do. Let's back up to before I made this change. Change these guys to... That's too far. 255 again. And then in the in here, instead of doing 24 minus, we'll just do I times 8. DK isn't very strict on timing. You've got another issue, I would assume. Could be. We'll find out. Why does that keep coming back? Answer, because I keep undoing stuff. And then let me... How's that look? Hooray! Correct colors. Goodbye, Donkey Kong. shut up, Sai. Let me be happy. Alright. How does something like that even happen? Don't look at me! I'll figure it out. No, I don't think that's it. Do you have to emulate scan lines to do an NES emulator? No, probably not. Well, it depends on what you mean, right? Oh, I should get rid of that bit. It depends on how much, how compatible you want to be, how much hackery you're willing to do, etc., etc. Yeah, so the scan lines are desynchronized, that's why. How does that happen? Is there a full frame buffer the NES scores to before it gets converted to scan lines, which you could put out directly in RCA jack? No frame buffer. I have a frame buffer because I need to draw something. So. This is probably not going to work. Yeah, no. What we need to do is if uop is equal to bgop noop assert sprite uop is equal to sprite op noop, and that they have the same scan line. Oh, okay, I didn't derive partial equal. What? Oh, that's sprite state, not sprite uop. My beat. Oh, you little bastard. What the hell? Used here after move. Okay, so it's correct, and then it suddenly is not correct. Scan line 39-ish. State.scanline is not equal to sprite state.scanline. And then we're going to start saying dispatch sprite ubop, dispatching background ubop. Why doesn't everything just derive debug? Oh god, it's going to be so slow. $38 peeps, quite the crowd, yeah. I'd time that out unless you requested a link to a Google protest. Yeah, alright. We'll do that. I don't know why. Can't you, like, tell it that you don't want links? I feel like there should be a way to do that. Chat settings. Messages caught by auto mod. Manage moderation settings. Is that what I want? Auto mod rule sets. No. I can just block hyperlinks, I guess. I don't really want to do that. Whatever. I'll just leave it off. Deal with it some other day. I lost the chat because I navigated away to look at moderation stuff. So if anybody said anything in the last couple of minutes, I did not see it. Well, this is obviously untenable. Mod sounds good. It's becoming a gathering. This is obviously dumb. What do I want to do here? Yeah, I assume it's because it's now after work in the Pacific time zone. That's why. That's where all these people came from. Welcome, by the way. You've stumbled onto the end of me failing to complete an NES in 2 weeks challenge. Hey, Weigel is a crow. You don't want to hear me do my crow impression into a microphone. Guaranteed. I wonder if this would run faster if it wasn't logging to terminal, but was instead logging to a file. I don't want to, like, stop it. Not a failure yet. You've got 2 more hours. Yeah, I probably will fail, though. Also, I would say I have 5 more hours because I don't live in the East Coast, and I never agreed to ending it on Eastern Time. But you know. Okay, so the problem is that the background is not taking the correct number of cycles anymore. The background stuff is like skipping. And I'm thinking it has something to do with sprites no longer overflowing immediately. We had this problem before. I didn't agree to that. I agreed to the make it through Mario 3 level 1 without glitches. I didn't agree to the timing. And considering there are no stakes, who cares? But in the end, it doesn't really matter. I definitely did have to fall. Yeah, I don't know what's happening. If this would hurry up and freak out, it would make it a lot easier. That's true, I did not disagree. necessarily think that that's true. I mean, it doesn't matter, right? I have nothing to prove to you. I'm probably not going to work on this enormously past 9 p.m. either way. Anyway. Extra day for the day lost to your cat eating the mouse. Fun fact for those of you who don't know, both of my cats are named after Linkin Park stuff. One of them is named after a song, one of them is named after an album. Also, this was not done by me, I should mention. Okay, I gotta stop just like scrolling and actually think for a second. One of them is named Faint, and one of them is named Meteora. So what are the weird paths through this code, right? It will hit all of the ones that are scanline dependent every time through. No, not Chester. They were found by the shelter the day that Chester died, which is why they were named after Linkin Park stuff. I don't really have any weird branches in here, do I? Maybe it's the sprite one that's freaking out, but I don't know why that would cause problems. Alright, we made it to the demo, so it should die any minute now. I don't know why the sprite one would matter, because I'm not even trying to render sprites yet, so... Oh, I think that was death. Hey look, death. Alright. Oops. Giant log. Hello, giant log. It's only 35 million lines of log. Those are Corgi numbers. I do have a separate array or something for OAM, yes. You know what? I bet what's happening is that who sets NMI occurred? It gets set in BGOP, so it should work. So starting from the bottom, let's go up to the last no-op. All right, so we had a no-op on scan line 39, and that matched, which is good. And let's see if we did anything weird. We clear the OAM. While this is happening, fetch name table, fetch AT, fetch background low, background high, increment horizontal. Are you supposed to be doing these things simultaneously? I feel like you kind of are. It's my NTSC timeline. Yeah, so it's not until the sprite starts fetching the name table eventually. So this is H blank right here. Maybe the sprite fetches the name table and PPU address is incremented wrongly. No, it doesn't touch that. It should, but it doesn't. Horizontal. Turn off sprite rendering and see what happens. Yeah, I don't know how easy that is, because some of this stuff matters, but let's see what happens. Oops, shit, cancel, don't do that. God damn it. I mean, darn. Sorry, Twitch. Hey, look, we exploded immediately because I'm still trying to pop stuff out of the queue. So yeah, we'll just get rid of all the spritey stuff. Get rid of this entirely. Oh. Yeah, because draw bits expects the cycle from the sprite state. That's why I can't turn it off as easily. Because the background stuff doesn't actually use the cycle in the same way. So that's why it doesn't work. Also, it's not even trying to render the sprites. It's doing all the math, but it's not actually rendering them. Why would you be an issue? Alright, here's what we're going to do. I'm going to turn off a lot of this. Junk. I'm going to leave these on. PPU.cycle count. $341, which does seem correct. And because the draw bits operate on the sprite cycle, that's probably why it freaks out. Because the sprite cycle's wrong, and it operates on the sprite cycle. And it looked like it was stuck in test sprite for way too long, so that's probably the op that doesn't work. for one of these reasons. Anyway. Okay, 177.039.00 minus 177.03356. 544. So that sprite cycle is obviously way too long. I guess that is true, Silverblaze, if you want to look at it that way. Sprite hit, sprite count, something. CPU.sprite count. Sprite count 7, checking overflow. I'm very tired. It's 11 p.m. and I've been doing a lot of physical work today. No problem. Sprite count less than 7. Continuing to check sprites. Done checking sprites, no overflow. No sprite hit. I bet you what happens is that we get done checking sprites, no overflow, and then this is wrong somehow. That is a good color scheme. I like orange. Orange is a good color. Blue and orange are complements. Yep. Alright, what do we have here, donkey.log? Sprite hit, sprite count. 4, 5, 6, 7. But we have a lot of no sprite hits. Should probably be printing the cycle. Yeah, I would expect a lot of no sprite hits, but I think this is the first frame that doesn't immediately hit all 8. How do we get out of here if there's no sprite hit? PPU index is greater than 252. Sprite index plus equal 3. Is there a version of this where the sprite index does not get increased correctly? If the y coordinate... Oh. So the problem here is that we don't double check whether we're done with the scan lines either. So we should check whether PPU index is greater than 252 or PPU, or not PPU, scan line is greater than or equal to 240, right? Secondary OEM clear and sprite evaluation do not occur on the pre-rendered client. Sprite tile fetches still do, which makes sense, so that should be correct. And then yeah, okay. That seems right-ish. More correct. I don't know how this would happen, though. It still exploded. What's the matter, you? No, that's still several hundred too fast. What the hell? I gotta start printing the cycle. Let's just do that. It's not a scan line. Right? Because this is 256 is the last one. That's why I used scan line when I meant cycle. I know there are very few sprite hits in DK, but because my OAM comes up as all zeros, it acts as though there's a sprite hit on the first line every time, because it's never written to set up sprites. Or something like that. I don't know. That might not be true anymore, but that doesn't look like it's dead. It didn't assert. It also doesn't seem to be doing anything. And I thought Donkey Kong would at least move, since he's a background sprite. Oh, hey, he's moving. I don't know why he's moving so slow. I guess because of all the printing. Oh, hey, it still died. Cool. Oh, it should probably be... This is almost right, but this is still a little bit wrong, because that's only checking if it is the very, very last cycle, but that's not when the sprite check would be necessarily, on account of that takes multiple cycles, because it has to like read stuff and whatnot. So this isn't always right. It probably needs to be what exactly? This is an else. if PPU sprite index is greater than 252. Well, okay, so this commits us to a test sprite call 2 cycles from now. Which means it should be, because we want the last one to be on 256, probably. Or no, if it's going to be reading from the name table, then it actually needs the last one to be on 255, which means that this would want to be 254, probably. But that wouldn't actually fix this problem because it counted a hit in 252. So if we get a hit in 252, I'm very confused here. So how big is OAM? OAM is 256 bytes. And we check it 4 bytes at a time. So even if we hit every time, which is the one that takes 4 or 8 cycles to read it out, I guess 8 cycles to read it out. If we hit every time, with overflow. This is a dumb problem. All problems are dumb problems, but this is a dumb problem. Because what happens is it got a hit on cycle 252, and so it tried to copy stuff, but it failed to do that correctly because it was too late in the cycle. I'd like to position the existence of non-dumb problems. Okay, they do exist, just not in emulation development, at least not for the NES. I should probably include the, what are we checking here? Y chord equals OAM latch because we read it out at sprite index, wrapping add. Okay. View.sprite index. How's it going, Nick? Haven't seen you today. Presumably you worked like a gainfully employed member of society. Hey, Nick, what pixel format does Gliam expect for textures? Because we couldn't figure that out. We just moved columns around until we got it right. Pretty good. Got my first paycheck. Awesome. That's great. Glad to hear it. Hopefully it's a reasonable amount of money. I honestly have no idea. Meeson has an OAM viewer. Yes, it does. People keep suggesting things to me that like aren't the problem that I have. And it's not that I'm not grateful. I appreciate it. I do. It's just definitely not the problem that I have. Well, that's interesting, isn't it? Sprite hit, sprite count 3. BSNES has some nice tools for SNES emulators. Oh, good to know. That took me a minute to figure out what the hell you were talking about. I can only claim a long day of trying and failing to write emulators. Alright, so what's happening here is that sprite index is wrapping around. So we're checking all of OAM and then we're just like continuing to check. Which is not right, turns out. So no sprite hit here, and then we had one here, and then we got a sprite hit here, and then sprite index. Yeah, it's even better. It's super. Look at what dumb thing I did. Woohoo! So sprite index is a U8. When I tried to check this, it doesn't. It's not right, is the thing. I wonder why I thought that was right. Well, I mean, I guess it is, but the problem is that it should happen first. Probably. Why don't I just move this up, huh? Just for the record, in case anyone was wondering, don't design your PPU this way. It was a cool idea for the CPU, and it worked out pretty well. Carrying it over to the PPU was a mistake. Should have done it differently. That happens sometimes, though. Where you think you have a good idea, and then you turn out to have a bad idea. Come on, Donkey Kong, throw them barrels. Using unstable Rust generators would be cool, but a bad idea. Yeah, did you read that blog post also? I think if I'd realized how deterministic the PPU was, I would have done it differently from the beginning. Is it just me, or does this look like I made it farther? Off for the night, about to crash hard. Good night, Silverblaze. Thanks for coming by. The only thing I've read about them is the entry in the Unstable Rust book. Let me find the NES Emulator Rust generators. There you go. Check that out. Have a good one, Silverblaze. Thanks for coming by. This doesn't look like a crash anymore, so that's good. No more horrible name table tearing. Donkey Kong's face becomes blue. So that's probably wrong. Or does it do that? I doubt it does that. I doubt the right-hand side of his body is supposed to be blue. Common bug because I'm off by 1 on my attribute table. Yeah, I didn't think it would. Yes, some of the ladders are supposed to be broken in half. That is part of how the game works. Alright, let's delete a bunch of logging so that it will run faster. The attribute table has 4 values that it serves for each byte. Yes. That can stay because we should never hit it. Those apply to byte to tile 0, 1, 2, 3 clockwise. Okay, next step is to render sprites, I guess. Oh, we did explode, eventually. It took a while. Boy, oh boy. I suspect that in trying to render sprites, I would quickly figure out why my sprite rendering runs off the rails. I just kind of like did that wrong, I think. Just sort of overall. But let's fix this attribute table thing first. So you're basically saying, Lila, that this part of my calculation is wrong. And I believe you. And since it's left-right, it's probably this bit. And probably this is supposed to be 2, and this is supposed to be 0. But let's double check. Attribute tables. The best emulator errors are the ones where the documentation is wrong. Yeah, I've hit more than a couple of those. NES Dev is a very valuable resource with some pretty critical issues. So, if tile mod 4 okay, so let's work through this real quick, since we already almost got it. So, tile mod 4 is equal to, there is less than 2, gives you D0 or D4, right? Tile, or not tile mod 4. Well, tile mod 4 is greater than or equal to 2, gives you D2 or D6. Scanline mod 32 is less than 16, gives you D0 to D3, and scanline mod 32 is greater than or equal to 16, gives you D4 to D7, right? I thought I had that right. So if the scan line is 0, then we stick with D0. Otherwise, we right shift by 4. Because that'll give us D4 through D7. And then, if tile mod 4 is less than 2, we don't shift because that gives us D0 or D4. And if we right shift, we get D2 or D6. This seems correct to me. So what am I doing wrong? Top left quadrant of this byte, top right quadrant of this byte, bottom left, bottom right. So that seems right to me. I guess I could just change stuff till it looks better. I hate doing that though. Still here, Lila? Yeah, he's still blue there. But the rest of these mostly look okay, although maybe there's just not two things next to each other except for him and that ladder. But the zero's right. Where do I select the palette for the 4 tiles? Right here? Is that what you mean? This bit? Or do you mean in here? Which I guess would be part of pixel address. Yeah, you must mean this bit. See what happens if I switch these, just for fun. Nope, made it worse. That's pretty unsurprising. What happens if we reverse these? I bet this also makes it worse. That does not appear to have made it worse. That made it exactly the same. Wonder if I have an order of operations problem here. That would be sort of embarrassing. Yep. Nope. That would have been too easy, I suppose. Although I guess I still have this wrong. Score text is also wrong. What do you mean? It's right now. Okay, so it was broken when I had those switched. Yep. That's believable. So I don't get it. I don't understand why it would be just wrong in that one place either. Maybe it's the only place that it's also wrong on the other side of DK. Oh, is that why those barrels look weird? I was wondering about that. That makes sense. I think I'm just like off by 1. Somehow. I don't know how I would be off by 1. You only select a single pallet per 2x2 block, right? I guess. I guess. I don't know. I mean, this is what I'm doing. I'm checking. So if the scan line mod 32, because 32 pixels is 4 tiles, is less than 16, so we're in the upper 2 of those 4 tiles vertically, then don't shift. Otherwise, shift by 4, which matches this thing, because you don't want to shift by 4 if you're in the upper 2 tiles. And then, if tile mod 4 is less than 2, don't shift. Otherwise, shift by 2. Because if you're on the left-hand side, you do not want to shift by an additional 2 bytes. And if you're on the right-hand side, or 2 bits. And if you're on the right-hand side, you do want to do that. And I guess I could do this, and it should, in theory, be the same. I'm just kind of playing with stuff now to see what happens. This is clearly a left-right problem, so it's not anything to do with the scan line. It's only to do with the tile. Okay, so that maps out the whole 16 by 16 block. At least as my thing assumes it to be. I think, anyway. Right, let's just not do that at all. And just take the last 2 bits no matter what. And then I can look at what that looks like. It's weird that it's wrong on the 2 edges. This might take a while to finish. Yeah, no kidding. I'm going to not succeed in my challenge, which was supposed to be to run Super Mario Bros. 3 today. But that's okay. I enjoyed learning and executing, and I'll think about whether I want to finish the project on a slightly longer timescale or not. I'm going to look at the score again real quick. It's all such a pain in the butt. So here and here. I don't understand. That doesn't really make a lot of sense to me relative to how this is supposed to work, because is it your tiles? I thought about it and I decided to give you the extra 3 hours. Well, that's nice of you. It's 2x2 tiles inside each 2x2 block. What does that mean, Lila? That doesn't make sense. Did you mean 4x4 block? Right. One attribute byte covers 16 tiles in total. So you must have meant 4x4. And so this is 4 tiles across. This is 4 tiles vertically. My phone is ringing. I'll call them back. Okay, so man, this is very annoying. I use Google Fi, so it's ringing in my ears because I'm signed into Google. Okay, there we go. So what doesn't make sense to me is that it doesn't look like that's where the divides are. Why would I try tile mod 2? I don't like that. I did have that written down at one point, but it seems obviously wrong, so yeah, no, that made it worse. Or not worse, but just like differently bad. It made the odd ones blue. Which is what I expected it to do. Okay, so here's the thing, right? So if we run it the way that I think ought to work, zero and 4 and 0 and 2, yes. If I run it the way that I think ought to work, right? So we get these tiles are blue and these tiles are pink. And then these tiles in the middle are pink also, I guess. But these two move together because they're next to each other because it's a 2x2 block. If we do this, we end up with like a stripe across because it's a 1x1 block. But what I don't understand is if those two are in the same 2x2 block, how could it ever be different than it is? You know what I mean? Do you see what I'm saying? Right, because see, these are the even numbered ones are blue and the odd numbered ones are pink, or vice versa. I can't really tell which. Which is why I'm starting, like, my theory is that maybe the problem is actually uh, not related to this at all, and that I'm just off by 1. Yeah, the ladder is correct, and left of the ladder is wrong. Scan lines go top down, right? I mean, I guess it doesn't matter, because that would not be a... palette selection offset. Like, it is an offset, but whatever. And you had that same problem where Donkey Kong was blue and some of the barrels were pink? Scan line divided by 8 is tile Y. And then, so then let... Are you okay, Cat? What are you doing? Maybe I need to divide by 8 and then mod 4. I don't know why that would be different, but maybe it is. Nope, not different. Didn't expect it to be different. So that's the tile X, and that's the tile Y. And then what you want to do is if tile Y mod 4 is less than 2, right? So you have 0, 1, 2, 3, and the top 2 are less than 2. Then don't shift, because you want either bits D0, D1, or D2, D3, neither of which requires a shift. For tile X, if it's 0, if it's less than 2, you're on the left of this 4x4 block. And so you want to not shift by 2, because you want to stay with 0 or with 4. And if you're on the right half of the block, like, should tile be mod 8? Why? Would tile be mod 8? Mod 8 less than 2 or mod 8 less than 4? Yeah, it doesn't. Sorry, I don't mean to be rude. I'm struggling. Don't want to take it out on you, though. You're just trying to help. So this worked example is worse than like it's not at all helpful. I don't understand why they think this is helpful. Masking after the shift, yeah. Shift, then mask. Like, it's not that complicated, but somehow it becomes extremely complicated. Because people don't explain things well, I guess. I don't know. I'm getting salty. Are you okay, bud? Why do you keep yowling? Oh, you want to go outside. You're not going to go outside. We live in a 6th floor apartment. Big doofus. Alright. Each 16 by 16 pixel color area has one of 4 color sets assigned to it. 1 byte controls 4 color areas. Right. That's what I'm doing. It's not helping. Oh, hello, cat. Well, now I can't see. So it's fixed. I can't see the problem, therefore it is gone. Where's 8 bits? They were saying earlier how great it is to watch someone debug. I wonder if they still think that. Like, that's only 1 tile, right? Or is it 2, the barrel? I don't know how big a pixel is. The barrel's only 1 tile. Now you're saying it's 2 tiles. If it's 1 tile, then I don't understand how this could possibly work. If it's 2 tiles, then I sort of understand how this could possibly work, but not really. Okay, Okay, but width, right? Width is what I care about. Is it 1 tile wide? Sorta. I mean, all I can think to do is bring this junk back. The right... Wait, what? This is going to run extremely slowly. Oh, I guess it's not that bad. We can kill it now because it's wrong. And let's look at the log. Okay, so starting at the top of the image. These are all basically the same. Attribute 3. Okay, so this has got to be it right here. Right? Loaded F. Because that's the only one I've seen so far that is not symmetrical. If you accept my friend request on Discord, I can send you the pic. Suspicious? Nah, I'm just kidding. I don't see you. Oh, okay, there we go. I forgot I blocked you because of all the Ziff memes and not wanting to look at balls at work. Yeah, so it's got to be this F one because that's the only one I see that is not symmetric, right? They're all, other ones are 22 or 55 or whatever. So the F one here, the lower bits are all F, which I think means that it cannot be asymmetric horizontally, right? So actually I'm wrong. That's not the one. It's the 22 that would be it, right? Because 23CA, yeah, that's what I thought. Because the 22 is asymmetric in X. And so for these two tiles, which are the leftmost of the tiles, we get 2. And for the rightmost of the tiles, we get 0. That seems correct to me. That's the only thing that is that way. But it looks like it's being done correctly, so... Maybe I'm wrong about like what palette the attribute byte actually corresponds to. That would be kind of weird, but I was expecting a link to the palette page in here somewhere. Zero, 1, 2, 3. The choice of palette is controlled by bits in the attribute table. The left side of the ladder is supposed to be palette 3F08. Okay. Which is effectively 3F00 because it means an attribute of 0. Which is what I have, I thought. No, it's not. It's the opposite of what I have. Because tile 8 those are the same. 3F08 and 3F00 are supposed to be the same. Oh, you mean the palette. Okay. Yes. I end up with that. Exactly. Yes. AT of 2. I mean, assuming I'm looking at the right things. Which, these could be the barrels, I guess. Do you know what tile it is across the map? But yeah, so tile 8 and 9, which are the left side, end up with 3F08 because they have attribute of 2 as a starting attribute of the palette. And then the 10 and 11 have attribute 0, which is what it should be. Eight and 9, yes. So I have it right. Is palette 2 correctly addressed? Yeah, should be. DK is 8 and 9, right? The latter is 10 and 11. Okay, just checking. Background index 2, palette index 2, pixel address is 3F0A. Yep, that's right. Background index 0, palette index 2 gives you 3F00 because that's how that works. Background index 0 always gives you 3F00. Background index 3 gives you 3FOB. Yep. Background index 1 gives you 3F09. These all seem right to me. I wonder if my background index is wrong. Yeah. It looks like the background index is 0. And so it just ignores the palette index? At least for some of it. So for all of tile 8 and for half of tile 9 maybe? Not quite half. Palette 2 is F30, 36, 6. 36 is right. 6 is right. F is the background color, so it doesn't matter. And then... yes. So all of that's correct. The only thing I can think of... the only thing I can think of is if the background index is wrong. or like offset somehow. The background index comes in from the pattern latches. I wonder if this is wrong. God damn it. Fuck you, Vim. Let shift equal 7 minus cycle minus 1 mod 8. I'm telling you, I gotta be off by 1 somewhere. I don't know why. Maybe my attribute table shift is off by 1. Seven, 6, 5, 4, 3, 2, 1, 0. This is when it's supposed to get set. All gets set at the same time. There is no shift. I do not know what's happening. I wonder if it's a timing thing. Because I've got this, but I'm also still rendering a pixel. Does that happen first or after? It happens first. Oh god, I made it so much worse. Is my attribute latch correct? I mean, demonstrably no. What about it do you suspect might be incorrect? Okay, we have now returned to the status quo. When you set it, it should be delayed the same way as the BG index. You mean delayed until this one, the ink horizontal cycle? It is. Can't type. See, these are all updated at the same time. I set the attribute latch in the fetch attribute table thing up here. And then it doesn't get set until here. The low value in the latch should be using the new value and it should be using the old. It doesn't, this thing that I was looking at didn't seem to think that the attribute latch worked that way. That doesn't really make sense. But, damn it. I have too many tabs. Gotta close a bunch of them. Right, so I was looking at this diagram here. 2-bit palette attribute for next tile from attribute table. Just writes directly into this latch, basically, is how it says this works. That doesn't really make sense. Could just be that this documentation sucks. This makes sense to me as a problem. Oops. I wrote lattes. Come on, click over to the thing already. Hey, that looks better. Awesome. Thank you, Solarak. That makes absolute sense. It doesn't at all match the diagram, but the diagram clearly sucks. And then it's going to crash again because I still don't know what's going on with sprites. Hooray, we fixed the one tile problem that we had. Interesting that it hasn't crashed yet. I expected it to crash by now. Did I delete that assertion or something? Maybe I just deleted the panic. That seems way more likely than that I actually fixed that. Huh, no, I guess I didn't. Wow, weird. Oh, no, there it goes. Hey, look, it crashed. Oh boy. Okay, the next problem is gonna be sprites, obviously. I think I need to take a minute. I got a phone call that I should probably return. Yeah, I know. I waited until my guard was down. It's a right bastard. I wonder what happens if I just don't panic. I do need to stop printing so much. I think there's really only these two places that's printing right now. At least I know like where the problem is for the crashing. And let's see if the screen goes bonkers. It probably will. Just takes a while. Hey, there we go. Goodbye. You got to admit, it's kind of cool to look at. You got to admit it looks fun. All right. Well, that's great. We gotta render sprites. Yeah, I need a minute. I'm gonna get a drink and return this phone call. Let's see, what time is it? It's like 8:20 here. Lila, go to bed, man. Um, yeah, all right. I'll be back in like 5 minutes. No big deal. Okay, I'm back. Everything is fine. My mother does not appear to have spontaneously flown to another country or driven to Vegas with a strange young man. So, all good. And I also just wanted to point out, I was right. It was an off by 1 problem. I didn't know where it was, but I was right about that at least. Hi, Sai. Alright, so sprites. If we go to drawy bits, we've got basically everything that we need to do the sprite part, at least in theory. So what we want to do is we have the sprites. There's a mux, which has a truth table down here, which is fine. And then, so how does this work? Every cycle, the 8 X position counters for the sprites are decremented by 1. For each sprite, if the counter is still non-zero, nothing else happens. If the counter is 0, the sprite becomes active, and the respective pair of shift registers for the sprite is shifted once every cycle. This output accompanies the data in the sprite's latch to perform a pixel, which is the attribute data. The current pixel for each active sprite is checked from highest to lowest priority, and the first non-transparent pixel moves on to a multiplexer. So, hi cat. We haven't shown the cat in a while. There may be some new people who haven't seen him yet. This one is Meteora. He's very snuggly. And very cute. Look up here, buddy. Yeah, he's uninterested in y'all. So was meat spelled meat this whole time? I mean, in theory, it would be Meteora. This is his full name. I don't know. I call him meat because nobody has time to say Meteora. It's 4 whole syllables. It's too long. Okay, so what we want to do is basically, for each sprite, check the counter. Sprites. OEM sprites. Byte 0 is the Y position. Byte 1 is the tile index. Tile number of this sprite within the pattern table. Attributes for the sprite. X position of left side of sprite. Where's the counter? Is the counter the tile index number? No. The counter is this bit, right? And based on how this is written, I'm guessing this is in pixels, which explains why it's written as a counter. And since we reload OAM every frame, we should be able to deal with that. Sprite count. We reset eventually, but I don't remember when. if sprite index is greater than or equal to 8. So that's when we're currently resetting sprite count, which is probably not the right time because we're going to want to use it in the actual rendering. Well, whatever, I guess. So what we want to do is for I in 0 to 8, take a look at the secondary OAM. So let x equal secondary OAM I times 4 plus 3. What do we take as inputs here? Cycle and scan line, and cycle is equal to the x position. So if x is, hang on, how does this work for test sprite? Is the thing that does this for y. If x is less than or equal to cycle and x plus width is always 8, it's greater than cycle. Does that seem right? Yeah. Sprite is active. For each sprite, if the counter is still non-zero, nothing else happens. If the counter is 0, the sprite becomes active in the respective pair of shift registers for the sprite. 8 pairs of 8-bit shift registers. These contain the pattern table data for up to 8 sprites to be rendered on the current scan line. Unloaded sprites are used with an all-transparent set of values. So that's tile index number. So that would be the stuff that comes out of this, right? Probably we should actually load these shift registers when we do the name table reads and stuff, because that's what we do for everything else. Fetch NT for sprites. Do we have a ink horizontal for sprites? I don't think that we do. What do we use in place of that? Okay, we don't care about the name tables. We don't care about the ATs. We fetch the sprites. So what do we fetch them into? Fetch sprite low, fetch sprite high. Sprite low byte, sprite high byte. Oh, we don't even do sprite high byte correctly. And then in ink horizontal, which is what we would normally do, and probably what we should do here, is where we set all of this junk, except that it's for the next scan line. So we basically need to do exactly the same thing, except that we need to do it with some sort of index for what sprite we're looking at, which I guess we do have, right? We've got sprite index right there. So that'll be easy, I guess. Hi, Faint. How you doing? Gonna jump up on my lap? Come on, say hi to the people. You can do it. There you go. Oh, my fuzzy boy. Alright, this is my fuzzy boy. His name is Faint. He's very fuzzy. He's a good boy. They both love me very much, which is nice. Yeah, Faint is extremely photogenic. Unfortunately, he's one of those thank God you're pretty cases. So I actually need to do this way. What if I just read it out of OAM? Like, how bad would that be, really? The respective pair of shift registers for the sprite is shifted once every cycle. This output accompanies data in the sprite's latch to form a pixel. The current pixel for each active sprite is checked from highest to lowest priority. Kitty. Okay, so he's being very weird. He's holding up my monitor now. Okay, so cat. Basically, what we want to do is we want to just right shift by the difference between X and the cycle, right? In the byte, which is the tile index number. So for 8x8 sprites, this is the tile number of the sprite within the pattern table selected in bit 3 of PP control. Selects pattern table from bit 0 of this number. Okay. Bit 0 here is the bank. And then these 7 bits are the tile number, which doesn't make sense because that's too many bits. All right, so I've got this. I do have a get sprite base. Good for me. Okay. Go to the drawy bits. Let shift equal cycle minus X. Let byte equal ppu.mapper.borrow get byte ppu address. The address is ppu.getSpriteBase plus the tile index number, which I think, cat, tile index number within the pattern table selected in bit 2. So these are palettes, not pattern tables. The pattern table is this bit. and they are a kilobyte each, or more. Forget how much 1000 hex is. 4 kilobytes each, which, if you divide it by 8, probably gives you... Nope, still doesn't fit. Oh, but you need more than that because you need to add 8, right? To get the high bits. So that fits, right? You got 256 times 2 times 8. Yep. So in that case, what you actually want is plus the tile index, which is going to be secondary OAM I times 4 plus... Can you explain how is this emulator be any different than NES emulators on the web to download? It won't. I mean, except that it'll be categorically worse. If you just want to play NES games, you should just download Misen and play that. Or FCUX. The only difference will be that I wrote it, and that I now have the knowledge of how to write an NES emulator. Pretty much. Linux number is byte 1. I'm also going to go through and kind of like explain a lot. Like, I mean, for one thing, the whole development has been documented on Twitch up to this point. I've streamed every minute of it. I haven't done any work off screen. And I'm also planning to go through and do sort of a retrospective a little bit later. Times 16, is that what I want? Yeah. I'm going to do a retrospective either tomorrow or Sunday. Some things are coming up tomorrow, so it might have to be Sunday, but hopefully it'll be tomorrow, where I'll just kind of talk all the way through, like, here's why I made the choices I made, here's, like, the parts of the design that I would change, here's the parts I'm happy with, etc. So that hopefully will be of some pedagogical value, some teaching value. Cat, why? Why must you do these things? Have I done an emulator or interpreter previously? No. I just kind of... I mean, I've done a lot of software and stuff, but I've never done an emulator before, except I played around with N64 for a little while, but I never really got out of the stage of just, like, playing around. That's what I would really like to work on next, is N64 emulation, which is why I'm sort of questioning whether I want to finish this project if it's not tonight, which seems unlikely at this rate. Okay, so if I remember correctly, get sprite high. It's probably called fetch, yep. Yeah, same thing, you just add 8. This is obviously wrong, but I guess it doesn't matter. Can you handle all 64 bits? Who knows? Certainly not in a week. Plus tile index. Low bit equals low, right shift, shift, and 0x01. High bit equal high, right shift, shift, and 0x01. Let sprite index equal low bit or high bit left shift 1. Let palette or sprite palette equal secondary OAM I times 4 plus 2, and 0x03. Yeah, Ferris did an N64 Rust emulator on stream for a while. He didn't get that far, though. Yeah, I've seen a lot of that stuff, actually. It's really cool. Just didn't really, like you said, make it all that far. And also, my feeling about N64 emulation is that it is sufficiently bad that it needs to really be, like, experimented with, I guess. As opposed to just, like, done again in the way that NES gets done. This is wrong. His Virtual Boy, though, he did a really good job of that. I didn't watch that one, but I bet he did. Palette index, sprite index. And then we're going to look at the palettes again. It's around here somewhere. Hello, cat. Oh, cat, why? Oh, why? You need to lose like 3 pounds, cat. Chonky. Okay, where was I? Address is 310, 314, 18, and C. Mirror down to the background colors. So I guess that means that the sprite index has to be greater than 0. If the sprite index is 0, it's like not used. Oh, okay, yeah, that makes sense. Otherwise, it's gonna be 3F10 plus palette index as used 16 times 4 plus sprite index. So if the sprite index is 0, then it just like doesn't. It's not. It's transparent there. It'll draw the background color. Okay. Okay, that should work. And then we would write to the pixel and then return, I guess, because we're just gonna draw these only. Sprite color. Sprite color index. Alright, this will look kind of weird because we're not multiplexing at all. I don't even know what's going to happen. Probably nothing good. I'm just going to try and run it and see what happens. Yeah, pixel color is obviously wrong. It wants to be sprite color. And then return. Oh yeah, I need to put PPU in front of the secondary OEM. PPU dot, PPU dot, PPU dot. Expected U16, found U8. Okay. Ugh, why you gotta be like this? For this comparison, actually, we should just do ASCII16 here. Expected U16, found U8, on line 121. What's the status? Oh, hey, look, there's Mario. And there's a barrel. Ah! That does look creepy. Haunted Donkey Kong. This looks correct. Well, the sprites look correct in the sense that they are in the locations they should be in. Oh, and look, Mario died. Now we're back to the title screen. Ben drowned. Pokemon Black Edition or whatever it was called. Purple, Lavender Edition. I don't remember. But yeah, so like that's where Mario should be. And then there's fire coming out of the barrel. There's barrels coming down. So they're all in the right spots. They're just bananas. Okay. So that's cool. So first of all, well, I guess that makes sense because the y-index is the only reason it's in OAM in the first place. Hi, Sai. So I'm guessing it has one of the several problems that I had previously, which is not enormously surprising. So why does it look like that is really the question that one must ask at this point. It's even kind of the right color, so it must be getting the wrong data. Somehow. Oh man, this is great. I love this. So, what's the problem here exactly? Well, for one thing, I'm not adding 8 here. I definitely should be. Blow into the cartridge. I wish. That fixes everything. I mean, yeah. When you write, you write. Nope. That actually does look slightly better. Oh god, the barrels look worse though. I'm guessing the pattern table is not actually laid out the same way that the name table is. Blow into your USB port. Yes, yes, you're all very funny. Each tile in the pattern table is 16 bytes made of 2 planes. The first plane controls bit 0, second controls bit 1. Any pixel whose color is 0 is background transparent. Pattern table is divided into two sections, left and right. Blah, 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 blah. Find Y offset the row number within a tile. I'm confused here. Am I reading from the right pattern table? Yeah, probably. Sprite table is different from DK table, from background table. Do you happen to know which table it should be? The same pattern tables are used for background and sprites. Yeah. Okay. So we are looking at 3F11 and 3F13 and whatnot. Which pattern table, not even a little bit correct. That's palette RAM indexes, which makes sense because that's the address that I printed. Oops. This is the one that I want. The one I want. Woo-hoo-hoo, honey. You're correct. They're not. They're palette RAMs. RAID? Whoa! Hello, everyone. That is a substantial number of people. Thank you for coming by. You're just in time to watch my haunted Donkey Kong game. You see? That's Mario. That's a fireball. Those are some barrels and stuff. And then that happens, and I'm not sure why yet. But welcome aboard. John Blow Raid, really? Wow. That's awesome. Thank you. I'm rendering all of this inside an MGUI window. Yes, that is correct. So this is... Oh, yeah, okay. This is day 14 out of 14 of my 2-week NES challenge, which was issued by Sai in the chat, PSISP. The idea was basically to create an NES emulator that was capable of playing Super Mario Bros. 3 in less than 2 weeks. I am not going to succeed at that, it seems very clear. However, I've had a great time trying. I've learned a lot about how the NES works. Perhaps that knowledge is of sort of questionable value, but oh well. And I had a good time, and that's all that really matters. It's written in Rust, because I like Rust. Yeah, gonna get as far as I can. I'm not gonna give up. That's not how I roll. But yeah, so currently Donkey Kong is extremely cursed, and I don't really know why. It looked like these sprite addresses, 0 or F0, don't really seem all that sensible to me. Plus tile index, which is what's in the secondary OEM times 16. Is it coded in Java? No, it's coded in Rust. I like Rust. I don't get to use it at work. This seemed like a good chance to use it. That means that the index was 15. Rust is a really cool language. What do I have to use at work? C#. I use C# at work. Which is actually, a surprisingly good language as these things go. It could be a lot worse. That's interesting. These are all basically odd. How big is your binary? Good question. Absolutely no idea. Let's find out. 3.6 megabytes. I also like Rust, but haven't gotten a chance to use it at work. What are your thoughts after having written this? I still like Rust. The only place I've really run into a borrow checker type problem is a place where I said, I know what I should do here, but I'm going to do the wrong thing. And then the borrow checker will yell at me. And it did. And then I added RC and refcell, and then it stopped yelling at me. How many lines of code do you have? Also don't know that answer. A couple thousand, I would guess. It's mostly in the CPU, which is like 2300, and then in the PPU, which is like 1000. We're using Rust at work and are having a problem with the binaries being too big. Yeah, I've heard there are lots of things that you can do to like shrink them, but I don't have to care in this instance. Embedded C#, yes, I'm using Mono in an embedded Linux system currently at work. I'm operating at a much higher level of the stack these days than I have been in a really long time, so that's been interesting. But before that, I was writing a lot of C, some assembly, MSP 430 assembly. But in this new job, it's mostly been C# and occasionally C. Sometimes I get to dive into the Linux kernel, things like that, but not very often. I've forgotten what I was trying to do entirely. Okay, so the ASM is fast and small. Well, yes, but it's very slow to write. The biggest thing, honestly, about writing assembly for me that's irritating is having to do manual register allocation. Like, if there was a register allocator, I would be much more comfortable writing assembly. So is this really a Jonathan Blow raid? That's crazy. Was he working on Jai or some new game? Or I didn't even know he was on Twitch. Working on Jai. Ah, cool. That's where he streams his demos. Cool. That's awesome. I didn't know that. So, what could be going wrong here? I could be looking at the wrong address. I'm combining them correctly. The palette, I think, is right. There's a mirroring thing that I'm super not doing, but I think it doesn't matter yet. I mean, you can see where Mario is messed up, but it's not really the main issue. Here's the OEM stuff. Donkey Kong ain't gonna use no mirroring. I thought it did for Mario's sprite. I've definitely seen like half implemented emulators where Mario's sprite is like split in half and both halves are facing the wrong direction. I could be wrong about that, but I seem to recall it. Palette 4 to 7 of sprite, priority, flips right horizontally, flips right vertically. X position of left side of the sprite. That type of mirroring, yes. Most programs write to a copy of OAM and then DMA and AN. Not counting the OAM data right tick. Yeah, so I did that already. Okay, so 500K after stripping. I really appreciate y'all coming by, rating. I know this is maybe a challenging time in this project, but I'm planning to come back tomorrow at least, certainly, and I'm going to basically do a retrospective. I'm going to kind of talk through the design, why I made the choices that I made, what I would do differently if I had it to do over again, all that stuff. And if you're interested in that, it'll probably happen in the evening Pacific time tomorrow. So feel free to stop back by. This is just fun to watch. This horrible garbage haunted Donkey Kong cartridge. I guess I could also be copying the sprites wrong. Props for using MGUI. Thank you. It's pretty good. I mostly copy and pasted examples, but is this the world's first Rust-based NES emulator? It definitely is not. There was a blog post that went around the other day. Someone implemented an NES emulator in Rust using generators, which are like an unstable feature. Okay. So if I am secondary OAM, either I'm writing to the OAM wrong, or I'm doing the wrong thing with what comes out of it. This is obviously wrong. This is equally obviously wrong. Next challenge for NES emulators to do one in Jai. But does your emulator emulate randomized OAM dynamic memory decay? No. So what I was doing here is I calculated based on the tile in the scan line. And similarly here, pattern table map 0 to 16, 1 to 16. That's weird. Sprite data is delayed by 1 scan line. I did that already. This emulator, I'm writing it on Windows actually. Try opening the disk tray and blowing on it. Okay. So I think I'm doing the right thing in terms of if I go into the I wonder if the fact that I'm trying to cheat is what's screwing me up here, because I'm reading from Well, no, because it's all copied to secondary OAM. Although, no, I guess not, because you do the sprite fetches, right? Where's the NTSC timeline? Right here. We do fetch the sprite bytes during this section here. Due to the way the internal lookup. Yeah, so that could be a problem. It might be changing the pattern table. That'd be a little bit weird, but I guess not impossible. Um, hmm. The bar doesn't look from Windows. Bit 0 is the Y position, bit 1 is the index. The pattern table is selected through. Byte 1 is the index. Am I... Maybe I shouldn't be multiplying by 16. Maybe that's my problem. NESDev is an incredibly valuable resource, but it is not very good. Nope, that didn't help. Still got Funky Mario. Got a sprite hit. Is the Y index correct? The Y index of what? Of the sprite. I mean... What? Sorry. I mean, it's being drawn at the correct Y scan line, if that's what you mean. Or am I supposed to be using the Y location of the sprite to index into the sprite palette table? Or something like that? Okay, so let's take a look at the log. To select the correct Y value within the sprite from the pattern table. I am doing nothing of that sort, so probably not. So you're talking about basically this junk here, right? But for sprites. And so then I should add Y offset would be secondary OAM I times 4, which is the Y0 of it, except that you need to subtract 1 or something like that. Subtract 1 for the sprite's Y coordinate before writing it here. So I need to add 1, basically. And then the difference between that and the scan line you're talking about doing something like that. Yes, Solarak? Oh hey, we exploded even faster. Wonder why that happened. Using sprite address FF01. Okay. Oh, that probably wrapped around. Yeah. Nope, still explodes. Hmm. Scan line. Scanline 1, Y start 255. That's probably supposed to not exist. Gotta go falling asleep in the chair here. Yeah, you should definitely go to sleep. It's like 6 a.m. there. Night, Lila. So if the Y start is 255, we obviously shouldn't be rendering this. If PPU.secondary OAM I times 4 is greater than, what did we say it was? EF. Continue. Although really break is probably more appropriate. Hey, we still exploded. Cool. Scan line, Y start, Y offset, weigh a lot. So I'm thinking that was probably supposed to be 0. The Y coordinate is the OAM latch. If Y coordinate is less than or equal to scanline plus 1. You must subtract 1 from the sprite's y coordinate before writing it here. So I probably am just supposed to subtract 1 here. Nope. Cool. Cool. That is not what I was supposed to subtract 1 from. Am I reading the values from RAM? Yeah. Or directly from the cartridge. So the sprite values come out of the OAM RAM. Oh, hey, that looks way better. Well, okay. Not 100% better, but better. Improvement. Oh, no, now we've lost it. We've lost the plot completely. But that looked like an improvement for a minute there. It is reminiscent of a person. Exactly. It looked like a person vertically, but not so much laterally, I would say. Or really just not at all ever. It's totally possible. I like how Mario captured Donkey Kong in the second game. Yes, I also thought that was cool. Alright, well I stopped multiplying by 16 earlier. I don't remember if that was a good idea, but let's try it. This is a bad way to do software development. Don't just try stuff. Think about what you're doing and why it should work. This is 92 people are watching me. I feel sort of compelled to indicate that this is not a good design process. Oh, ow. Hi. Yeah, you're very sharp. Why are you doing that? Stop it. Yeah, it does all sorts of stuff. It's not obvious what's going on at all. At least not to me. That didn't make it worse or better, which is weird. Try adding 256 to the tile index. Why would I do that? Unless I'm already fetching from the second table. I'm not, but I'm fetching from the right table. Also, the tables are like 4 kilobytes. Unless I'm misunderstanding what you're saying. But the pattern table is 4K. So I would have to add 4096. $16 bytes per tile? Yeah. Because it's 2 bits, or... Yeah, it's 2 bits per color, and it's 64 pixels. So divide by 4, you get 16. 16 bytes a tile. Right. but I'm not multiplying by 16, although I was. It's very unclear to me like what the tile index is supposed to be. I wish this was better documented. The times 16 seemed like a good idea at the time. Like, that is close enough. Is the RAM a 1D array? Are the sprites stored linearly or in a 2D fashion? It's a 1D array, kind of. That looked pretty close, honestly. Oh, you know what I'm not doing, though? Well, no, I guess I am. I'm updating the shift. Because this should get called every cycle. Cycle minus X. Maybe I want to do it the other way. Maybe I want to do like 7 minus shift. This is almost certainly not right, but could be. I mean, I think that is correct. It's just not the problem. Oh, my hair's getting... You can tell it's been a long day. That, again, almost looks better. Mario just phased out of existence. That's not better, but... There's a thing about PPV rendering that said something about if the counter is 0, the sprite becomes active, and the respective pair of shift registers is shifted once every cycle. Accompanies the data in the sprite's latch to form a pixel. The current pixel for each active sprite is checked, and the first non-transparent pixel moves onto a multiplexer where it joins the background pixel. Never straw soloing in DK. Yeah, that's just because my timing goes bananas. It's not supposed to actually do that, obviously. Pattern table data. Add 4096 to the index. You think that's the problem, really? I don't, but sure. I bet it looks bananas at this point. Like, I was seeing Mario's head. No way am I 4096 bits off. That's interesting. Wonder if that helps. I'm going to try this first, and then I'll add 4096. Nope. He's so stretchy. And then things just decay. Okay. Yeah, I'm telling you, this pattern table thing is a dead end. There's no way this is the problem. Yep. Is it supposed to be times 16 or no? I have no idea. Maybe it's supposed to be times 8. Probably not. What did I break? Oh, I don't close the parentheses anymore. I need to probably get up and get some water and stuff. Yeah, it makes sense to me for it to be either times 16 or not times anything. Oh, boy. So I'm shifting by... Right, because it is 8. Yeah, that does look a little more stable. Not a lot more, though. Let me take a look at the log. I haven't done that in a while. How come that's getting hit multiple times for the same scan line? That doesn't make any sense. No, it does make sense for it to do that. Because it gets 6... Yeah, okay. It should hit it 8 times. 1 for each of the cycles, right? So 1, 2, 3, 4, 5, 6, 7, 8. Makes total sense. Y offset 7. 6, 5, 4, 3, 2, 1, 0. That all seems completely sensible to me. Sprite address CB. I feel like I should do that scene from Scott Pilgrim now where it's like, do you know that Pac-Man actually means Puck-Man? The sprite address increments each time. Each time what? You mean each scan line? Because it does do that. It shouldn't happen every time it hits the OAM because the byte should have 8 bits for the 8 pixels, right? So since this gets called every pixel, this looks correct to me. This doesn't necessarily look as correct. Although I guess it could be. Um, I should probably be putting out the tile index also. I feel like it has to be times 16, otherwise we'll never make it to using all of the pattern table, right? Because if the tile offset is 255, you multiply by 16, then that is reasonable. So the tile index times 16, I'm pretty sure is correct. Although maybe I should do it down here so it doesn't show up in the logging. There is also a sprite on the title screen for the cursor. I don't see that at all, so that's interesting as well. Let's look at the log, see if there's anything obvious. Tile index 204, sprite address CC7. Because the Y offset can be at most 7, and then when you add 8, you get the next thing. That all seems basically correct to me. It's a little weird that it's just linearly incrementing as though there was a sprite on every line. So maybe that's screwy. Okay, so not every line, starting at scan line 51. 330, 331, 332, 333, 334, 335, 7, and then nothing else happens for a long time. 3B8. I don't get it. These all seem like pretty reasonable addresses. Scan lines, oh, Y offset 9. Well, that's not right. So that's cool. Unless it's a double tall sprite. Do we have those? That would be weird. Scan line 67, Y start 59, Y offset 8. Okay, maybe it is a double tall sprite. That's sort of surprising. That's weird, because it just starts at 8, and then drops down to 4, and then 9, and then 5, and then 10, and then 11. Okay, so something has obviously gone screwy by that point. So you know what? You're right. You're absolutely right that there should be a sprite in the title screen. Like, that's what that is right there. Scan line, cycle. So let's just run this for like just a second and then kill it and then look at what's happening. Oh, okay, maybe not then. It seemed as though there would be one, but Nope. Okay. So I'm not even seeing one. This must be Mario. Well, that's interesting, isn't it? Cycle 73 every time. That doesn't seem right. Because we should hit it 8 times across. And yet we don't. Let's also print the X value, shall we? This will, surprising no one, turn out to be something very dumb once I figure it out. X is 66, and we're on cycle 73. (73 minus 66 is 7. Shouldn't this have been true for every cycle before that point? Like, so if X is 66, right, and cycle is 66, then X is less than or equal to cycle is true, because 66 is less than or equal to 66. And 66 plus 8 is greater than 66. So why wouldn't we hit this previously? I guess if the secondary OAM is causing it to terminate early, that doesn't really make sense. So that suggests that this is just like not correct. Because all of these writing to offsets, those should be relevant. Right? Like, that shouldn't just happen for no reason. And this I should be able to just run because there should only be, like, there should be sprites already that are getting hit. And there are. Writing 255 to offset 0. That doesn't seem right. $255,000, huh? Well, this is just what you get when you're hitting empty OAM, and OAM hasn't been initialized yet. So let's go down to the bottom. $254 to offset 0. Whoop. Okay, so here you go, right? 126 to offset 0. So it should trigger when scan line is 126. Or around there. Am I like overwriting the sprite memory maybe? Like maybe I'm writing to it twice in the same scan line? Let's start printing out when we hit scan line boundaries. Boy, I've been live for a really long time. Okay. So for scan line 123, or 113, we write 206 plus 8 is 214. Yep, seems right. 206, 206. 5 is the tile offset, if I remember correctly. Here's my OAM tab. Oop, whoa. Yeah. So 1 is the tile offset, the tile number of this sprite within the pattern table. So that's 5. Attributes is 0. X position is 48. So how come we don't hit this at all? It really does seem like we ought to. Do I ever clear secondary OAM? I do in clear OAM, which I guess makes sense. But I think I might be screwing myself up there. Because if we look at the diagram, we clear OAM, and then we evaluate it, and then we fetch. But then while it's getting drawn, we're clearing. So, okay. Pretty sure I know what's going on. tertiary OAM. So many OAMs. Yeah, I mean, that's obviously not what it is. But this is supposed to fetch into a bunch of latches and junk, and I was just assuming that it was okay to not do that, but it obviously is not okay to not do that. So, yeah. I don't know, maybe. We'll see. Tertiary OAM. Sprite index as usize times 4 is equal to secondary OAM. Sprite index as usize times 4. Oh, is he supposed to appear earlier than that? One of the problems is that I don't know this game very well at all. And so this one is going to become sprite low byte, I guess. It's not a door, it's an oil drum, isn't it? That's probably not what we actually want, is it? No, it's not. S12G, S13G. Okay, and then in the draw bits, congrats on 61 viewers. Man, Nick, you don't know the half of it. I got rated by Jonathan Blow, and 250 people showed up, and they've been slowly trickling off ever since. Nope. Not kidding. Sounds like it would be kidding. Isn't kidding. S secondary, tertiary. Yes, that's true, you are, and I really appreciate that. Some folks are staying, and they're mostly the coolest folks. This delimiter is not closed properly, huh? On 73. I'm a bit surprised he'd rate a Rust stream, though. I was surprised, man. I didn't even know Jonathan Blow streams, if I'm being perfectly honest with you. And I know he's not maybe the, oh, hey, look at that. That's bright. Oh, well, okay. I mean, this is progress for sure. And now everything is dying again. It's kind of fun to watch the game just melt. Whee! I can't get over that. It's so funny. Okay, is this what the thing is supposed to look like? The stage select thing. Does that look correct? That. Do not adjust your television. Okay, no, that's not what it's supposed to look like. Alright. I don't think so. Kind of small. You know what? I should just Google it. Donkey Kong NES title screen. Oh, I didn't realize that was YouTube. I just want an image, please. Please give me the image. Thank you. Jesus. Okay, so that's what it's supposed to look like. And what mine looks like is almost that, but like a little small and with a weird extra line. Alright, so let's run this and then close it while we're still on this screen. At least it's showing up now, that's progress. Okay, so we wrote 126, 162, and 56 on scan line 134. And then we hit it on 56, 57, all the way through. Except the Y offset is 8, so that's still wrong. Which is, that actually 100% makes sense. Wonder how that happened. Okay. I think when I write this, I should not be subtracting 1. Which never really made sense to me anyway. Where'd it go? There it is. Oh, that looked better for a second. It just was under Twitch, so you couldn't see it. Okay. Hey, that looks about right. Maybe a little bit small or offset. But definitely better. Yeah, so that's got a 1-line vertical offset, I think. Wish I could make it stop doing the demo easily. Yeah, so that looks like it's got a 1-line vertical offset, which is not tremendously surprising. So I'm going to add that back in, and then I'm going to add this in so that we get the right offset. Have I hooked up any input yet? No! At this point, my goal is basically to run this Donkey Kong demo without horrible destruction, and then call it a day. There's absolutely no way I'm getting a Mario 3. I'm not sure that made it better. Oh, goodness. Can I scale the output? Actually, Nick, you're here. You can tell me how to do this. So, I made a texture, and I made a window. Can I scale the texture somehow so that it's easier to see in MGUI? Like if I change this right to be bigger, will that work? I just copied your code, so I assume you know. Ah! Hi, buddy. Wish you guys would knock. Something. Oh, hey, it exploded. I haven't touched anything in like a month. Yeah. I bet if I multiply it here, it will also not work. I have no idea how to do this. Oh, no, I bet it would be down here, the image that would need to change. It's a good kitty. Okay, yes, that's fair. Width times 2 as F32. Height times 2 as F32. Oh, hey, it did get bigger. Awesome. That's way better. Now it can be haunted twice as large. Let's watch it be horrifying. Poor Princess Peach. Yeah, probably. Probably it's because of NES dev. Oh my god. Whee! Yeah, it's much easier for me to see as well. I didn't realize it was going to be that easy to do. Hammer looks sort of correct somehow. Yeah, some things, I was looking at the barrel and it was like rotating, but not around the correct axis. Goodness. Okay, this needs to be bigger. Let's say 768 by 768. Probably are going to want to be zeros, or decimals, yeah. Is it just me, or does Mario look like a mimic? Yeah. It's not just you. So that still looks like it's floating an extra line up. And of course everything is garbage. Although at least Mario appears on screen at the correct time now. The hammers do look almost correct. That one does in particular, although it's squishing the background because I haven't implemented priority. Oh, Mario got the hammer, and now he's gotten everything worse. Oh, and now everyone's dead. Okay. I suspect that when sprites collide is when it explodes like that. Anyway. So, actually, let's stop doing this, but keep doing that and see what we get. When Sprites Collide sounds like a good title for a book. I was thinking that it sounds like a track that would be playing in the background of Tony Hawk Pro Skater 2. Nope, that's worse. It's on the right level, though. Let's take a look at the log. Because, yeah, Y offset 65535. Aw, yeah. Pretty sure it's a Power Man 5K song. Is that who sings that Worlds Collide song in the Tony Hawk games? And now you're floating again. What the hell? Oh, this is what it's like when worlds collide. Are you ready to go? 'Cause I'm ready to go. What you gonna do, baby? I mean, I guess when I'm detecting the sprite would not change. Regardless, right? So it's not very surprising that this is happening. So what if I just got rid of this? Oh, God. Oh, God, what happened? Ah! Oh, I broke it so bad. Cool, cool, cool. I really shouldn't be getting this fixated on a 1 pixel offset. It's not a huge deal. The out of range sprites is being detected. Imagine how much more broken it could be if you had input. When you write, you write. Alright, whatever. That's good enough. Who cares? So we gotta figure out what's wrong with Mario and Princess Peach. Princess Peach. Alright, let's look at the log. See if it's doing anything obviously stupid. Doesn't seem to be doing Y offsets greater than 7 anymore. Oh, it is. Just not as often. Scanline 8, cycle 0. Weren't there some PPU test ROMs? I mean, probably. I asked in the Emudev Discord if that was a useful thing. And they basically said no, but what do they know? Just pro tip for anyone out there who wants to write an NES emulator, don't design your PPU the way I did. It worked pretty well for the CPU. It's pretty bad for the PPU. Is that part of Peach's head, like, way over here? That's weird. It does sound like PP. You're right. When you're right, you're right. Oh, whoops. Didn't mean to do that. My bad. Oh, well. We'll just stop it sooner so we get better logs. Hi, Mario. Goodbye, Mario. Okay, so we do hit this problem. Sprite 0, scanline 8, cycle 0. What are you, scanline 0? I'll walk myself out. Why are we writing 0 to every address? That doesn't seem like a good thing. I mean, I guess this is at the very beginning, right? So here's something that's more real. Here's a Y offset 15 up here. So obviously something has gone completely off the rails at some point. So I sure wish I could figure out when that happened. I think so 24, 213, 180. 24, 214, 188. So those are two sprites that are right next to each other at scanline 214. This has got to be Mario, right? And then, or no, on scanline 24, not scanline 214. So this is probably Peach. And then we hit sprite 0, 24, blah, 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 blah. Right? But how come we don't hit the next one? Because we should. Cycle 88 should work. Because X should be 88. Right? So why don't we hit the next sprite? Why don't we hit sprite 1 on cycle 88? I am returning, but only, like, this should get called for every pixel. So that should be okay. I'm only returning if it's a hit. The only reason I might not get it is if the tertiary OEM is telling it to skip. Do you agree with that? That the return is correct and should not cause this problem? That's okay. That's a thing that happened. It's going incredibly slowly. Awesome. It must be skipping a lot of sprites. It's so fuzzy when it's scaled up. Could you please advance on to the demo, Mr. Kong? Standard in and locking and IO buffering, mumble mumble. Yeah. I mean, I know logging to a file is not fast, or I mean, logging to standard O to a file is not fast, but still. It must be skipping a bunch of sprites every iteration, which means this is not like a great thing to do. You know what I should do is I should invert this test. Bet that runs a lot faster. Yep, it does. Okay, yeah, so this is what we were looking at before. It's right here. For scan line 24, we check sprite 0 a lot. That makes sense. We were printing on every pixel. But not checking sprite 1, you'll notice, even though we definitely should check sprite 1. So what the hell? I must not be copying something correctly. into my ridiculous tertiary OEM. And guess what? I'm not. Probably. Okay, so I do all of these copyings in fetch sprite low. Based on sprite index. Seems like that ought to work, don't you think? When do I update sprite index? It's reset to 0. Increments on OAM read. Gets reset eventually. A lot of this seems very wrong. Maybe I should just write to tertiary OEM when I write to secondary OEM. Instead of... Right. So... Da, 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 da. Ugh. Every once in a while, I look at myself in the stream camera, and I'm like, oh, I have terrible posture. Alright, let's get rid of you, and I guess also you, since that doesn't seem to be my main problem at the moment. And now you should run much faster. Wow, I can't believe 50 people are still sticking around. Oh no, I made it worse. I love the infinite tree of hammers. That's great. So, what? So, for some reason, we hit this on cycle 0 because x was 0, even though it's definitely not supposed to be 0. For sprite number 2. Ugh. Yeah, it's not getting cleared, but that's like the whole point. So the tertiary thing is obviously dumb. Like, it doesn't make any sense as a concept. I need to take a break. I need to walk away for a minute. I need to get some water, pet my cat, take a leak. I'll be right back. Give me like 5 minutes. Holy shit, what? Was that you? I don't know how many of you just heard me kind of freak out, but I came back and my computer was trying to restart. I think possibly my cat stepped on the power button or something. But yeah, that happened. I guess it's good that I came back when I did. Let's just make sure that things are still as broken as they were and no more. Okay, good. Man, that's a hot mess. Okay. So, I thought about it. And tertiary OEM is a bad idea. It was a dumb design. I should never have done it. I'm going to get rid of it. And I'm going to do it the right way. So, if we look at the documentation, which is mostly pretty bad, but there are 8 pairs of 8-bit shift registers, which contain the pattern table data for up to 8 sprites. We're going to actually do that. Struct PPU down here, instead of having a nonsense tertiary OEM thing, is going to have OAM pattern regs. 8 pairs of 8-bit shift registers. So that means 8-bit eight pairs 8. So that's that. Then there are 8 latches, which contain the attribute bytes. This is OAM attribute regs, which is just a U88. And 8 counters, which contain the X position. It's going to be U88. Y'all can hear me and see me and whatnot. Just making sure, because everything went all screwball. Okay, good. Thanks. Just checking. All right, so then where we mess with tertiary OEM in here, we're going to get rid of it, obviously. And then we're going to modify the sprite fetch stuff here to do the fetching along these lines, right? So we know exactly what needs to happen. The shift remains, the tile index, the Y offset, all of this can just get copied. So we're going to move that. Tile index, Y offset, address, that all just moves straight across to right here. And then we can get rid of this bit. Oh, this is sprite high. My bad. We want to bring this over right here. Get rid of that, get rid of that, get rid of that. And then we get the low byte, and we get the high byte. And I think what's supposed to happen is that that's not supposed to chunk into place until some sort of analog to the increment horizontal thing. But it doesn't actually show that in here. And so we might as well just write it directly to the flags. Okay. So that's sprite low, and then what we're going to do is, instead of doing this, we're going to do PPU dot, what did I call it? Pattern regs. Whoop. Hi, bud. Actually, you know what? I am going to leave that in place. I am going to create some sort of analog to increment horizontal. Because it seems like the right thing to do. So you want to fetch the sprites. And then we'll do the same thing here. Get rid of base, index, and address. And then all you need to do is add 8. The high byte. Okay. Sprite op inc horiz. Ah, buddy. Stop it. Reduce the clawing. I know you're hungry, but you've been fed. Okay. And what we want to do here is basically just capture stuff into those latches, which we should have all of it at this point. So struct PPU, we've got OAM pattern regs PPU dot sprite index. Sprite index. We're not going to bump the sprite index until we've done this. Sprite index times 4, or no, just sprite index, 0 is going to be PPU dot sprite byte low, or sprite low byte. 1 is going to be high byte. What's the next thing is attribute. OAM attribute regs sprite index equals secondary OAM sprite index times 4 plus 2, I think. Is that right? Plus 2. Whatever. Yeah, by 2. Okay. And then OAM XPOS regs CPU sprite index secondary OAM. Whoa, hi buddy. PPU dot sprite index times 4 plus 3. Now it's not going to build because a bunch of those are not U sizes. Whoa, what happened to you? Reset. Okay, better. Yeah, that's what I thought. Gotta cast it to U size. Gotta cast it to U size. Gotta cast it into U size. Okay, tertiary OEM is dead. Gotta fix a bunch of stuff that references it now. Draw ye bits. I'm just gonna tag out all the sprite stuff for now. On account of I just want to make sure that other stuff builds. This should obviously be secondary OAM. Let sprite index equal CPU.sprite index as U size. Sprite index. 736, gotta do the same things. PPU does not have this field. That is true. There's a bunch of other fields that it does have that you were expecting and don't have. OAM, attribute, regs, 08. OAM, pattern, regs is 028. And OAM XPOS regs is also 08. Not found in this scope because it doesn't have the thing in front of it. PPU dot. Does that build? Looks like it builds. And it should still draw the background junk. Except it doesn't, so that's cool. Wonder why. Oh, well, okay. That still shouldn't have happened, but instead of calling wait mem, we need to call inquiries. It's an improvement. Now there's only one bug. That is a way to look at it, I suppose. I still have the return in there, don't I? Oh, did it just explode real fast? Cool. 715. I thought we reset sprite index when we move out of this. Well, we reset it here, but that never happens. We reset it in check overflow. Have you considered putting a back image on your side to be always on top so that you see which part of the screen is hidden by your webcam? I have not. I probably should do something like that. So basically, the way that this all kind of came about, I had no preparations for streaming really at all, and so I just kind of threw something together. My plan is that after finishing this challenge, I will take some time to really clean everything up because I have really enjoyed the streaming portion of this, and I would like to keep doing it. Yeah. But the short answer is no, I had not thought about that at all. So thank you for the suggestion. I will definitely do something like that. In the meantime, do you want me to move it? There's not really anywhere great to move it to, I guess. Oh boy, falling asleep here. Okay. There isn't anywhere great. Just do you thought I suggested? Yeah, no, I appreciate that. It's an excellent idea that I should really figure out how I'm gonna do. Okay, so we reset that at that point, but then we use it in a bunch of places. And then we reset it again when we're done checking sprites. And there's no overflow. Is there some other time? And then in write overflow, we use it. Increment by 5 and stuff. How does this happen to me exactly? Because the sprite index should be... I want to see what I was doing before I added all this junk. As long as I can avoid jogging my elbow and breaking the... Okay, so it was pp.sprite index as you size times 4. So what gives, bucko? Oh, hi, buddy. I might be incrementing it twice, I guess? Hello, cat. Hello! I hope you all saw that. It was a pretty impressive leap. Nope, the only place it's called is in here, so... Oh. Yeah, that would do it. Dingus. Okay. Just call it 1,000 times in a row. That'll be totally fine. We still exploded. Why did we do that? Hold up. You're so very in the way. Okay. 1, 2, 3, 4, 5, 6, 7, 8, but then you explode here. So why are you going back to fetch sprite low afterwards? That doesn't really make sense. This is obviously too much logging, but it will definitely help me find this problem. And it seems to be happening very quickly, so. Kaboom! NTAT low high horizon. TAT low high horizon. NTAT low high horizon. 6, 7, 8. So we're just not bailing at the right time for whatever reason. That's a bit odd. Oh, okay. Yeah, that makes sense to me. Just kind of goofed it up. Okay. Gonna want to stop logging every single sprite operation, probably. Boy, my cat is mad. Alright, let's see. Basically just explode immediately. Cool, 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 cool. Let's run with a backtrace. We can see what happened. Get byte PPU. What? Well, that's not at all helpful. Thanks, pal. What the hell? Maybe I should log all the sprite UOPs and see if I'm doing something completely weird. Or is it dying in rendering? It didn't look like it. Oh, I know why it was terrible in terms of the backtrace. It's because it's optimized. Just let it run in debug mode. It'll take a long time to compile, though, probably. Okay. Fun once, call once. Closure. Okay, so they happen in a background UOP, it looks like, because there's an I8 here. At 227. She's right here. Oh, it's had to add with overflow. Which probably there's not supposed to be overflow either, is there? What? Rust debug mode with wrapping math. There's got to be a way to do this. Don't do this. Rust C-Z force overflow checks off. Ugh. Okay. So it's probably this then, right? Like, kit byte PPU. If adder greater than or equal to 3000 U16. Accessing invalid address. Adder. Oh, we don't make it that far because I was running in not release. FF01 looks like a wraparound of some sort. Didn't I have this problem once before? I'm really flagging in terms of mental processing at this point. So this is wrong, I guess. This is what's exploding, yeah? Why is that happening? Presumably because this is wrapped around. I've already got a thing that debugs this. Let's just take that and smear it around a little bit, huh? So sprite I becomes sprite index. Scan line and cycle stay the same. There is no X, but we don't care about it either. The Y start remains the same. The Y offset is the same. And the tile index is the same. So all we need to do is get rid of the X, which is right here. Oh yeah, this needs to be secondary instead of tertiary. Oh, local variable, sprite index. Kablam. Yeah. Y start 255. So I think what we need to do is we need to do sprite or Y start, right? This. If Y start is greater than or equal to EF, or is less than EF, do all this junk. Right, because it does not matter what you get, it just is not going to work. And then we'll do the same thing here. Ow! Please stop doing that. Oof. Hello, kitty. It's because I didn't move this outside. Okay, we made it this far again. We're not rendering any sprites because I turned them off. We're printing every cycle or every pixel or something, which is why it's running very, very slowly. But progress at least, because it's not just dying all the time. Alright, now we need to fix the spritey bits right here. Oops, too far. I have my vimRC set up so that hitting JK back and forth really fast is equivalent to what would normally be escape. Which is great, except that sometimes if you're scrolling down and then you want to like change directions, you'll accidentally exit out of visual mode, right? So if you're doing this and then you try to turn around, it goes away. And if you're going down, then you have to like wait for it to realize you're not about to hit K to go to the next line. So those two things are sort of annoying, but hello, cat. Wish you would make up your mind about what you want to do. Okay, so none of this is going to work, obviously, because we don't have a tertiary OEM anymore. OEM? OAM. What we do have is whatever I called those things. Pattern regs, attribute regs, xpos regs. So X is going to be OAM xpos regs. I. And then let Y start equal, or actually, do we even care about that anymore? Yeah, we do. Do we? We don't. Okay, so that should be gone. Because we don't even have access to it anymore. So that'll go away. We don't have a tile index either. All this junk goes away. And then the shift still stays. The low comes from OAM pattern regs 0. The high comes from OAM pattern regs 1. I1 and I0. Low bit works. Sprite index works. Sprite palette comes from OAM attribute regs I. Then this works. Then this, I guess, works. Seems like it would work. And so will that. So hopefully this will run and everything will be great. But if not, I'm going to go to bed either way. Anyway. No field tertiary, whatever. Right here, right? So we gotta... I mean... How do you even check this? I feel like the rendering thing mentioned this. Right? Oh, I guess we just write the... It should be a transparent color, right? Unused sprites are loaded with an all-transparent set of values. So, okay. So what we're gonna want to do in Ink Horizon is probably, or maybe not even there, maybe in one of these. Yeah, in one of these. Right, we'll do else. Transparent. Except I'm not totally sure how to make that do. Oh, I do know how to do that actually. It's by making the sprite thing 0, right? Because, yeah, so if the sprite index is 0, which means that we just load them both at 0, so that should work fine. PPU.sprite low byte equals 0. PPU.sprite high byte is equal to 0. Right, and then we shouldn't even have to do this. It'll just be invisible. OAM attribute regs not found. Is that not what I called it? Oh, it's because it needs PPU in front of it. Of course. Cats have very high body heat. Anybody who has not met my mischievous cohort, this one here is named Meteora. Can you see him? A little lower. This is Meteora. He's very sweet and very pretty and kind of annoying sometimes, but mostly good. Dang old webcam. There we go. So what's going on? Hey, that's almost right, but not quite. Do 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 do. Yep. Y is Y offset 8. Sprite 0. Scanline 8. Y start 0. Dum. Okay, maybe that's just what happens right at the beginning and it doesn't actually matter. Oh, I forgot to delete all these. That's probably why it was running so slow. Oops. So that's a little iffy. And this is even more iffy. Seems relatively stable compared to previous times that I've tried to do it. I mean, it's a little bit wrong still. And now Peach is melting. So it's not perfect, but... Alright, so... Let's just take a look at this here. My 3 billion line log file. Ugh. Alright, I'm going to try to run this and just kill it nigh immediately when we get Mario on the screen. That was too fast. Okay. So, what happened here? Oof. Excuse, bud. Sorry. Okay, What's the one that I'm looking for in fetch sprite low? By the way, everyone listening and watching, I want to say thank you for coming out, sticking with me this long. I can't believe 52 people are watching me fail to debug this problem. It really means a lot to me that you're taking time out of your evenings to do that, and thanks to Jonathan Blow and everybody who came from his stream as well. That was really unexpected. Okay, well that's a problem. Y offset of 65535 is not what you want. Which means that you should probably either subtract from a scan line or subtract 1 when you write to secondary OAM. Yeah, so that probably doesn't help. That might fix our funky little star problem. Yep. Star looks much better. Doubt that Mario does. Nope. That makes sense to me. Alright. I think I'm going to call it. I'm feeling pretty worn out. It's kind of a bummer that I didn't make it even to the point of running the Donkey Kong demo flawlessly, but you know what? That happens sometimes. I've never done an emulator before. This is a fairly aggressive timeline, although I'm sure that someone who's a little bit more experienced and who doesn't make quite so many bad choices would be able to achieve it. I want to make sure and let everybody know about the EmuDev Discord. Let me drop the link to that. That's the origin of this challenge. It came from someone there named Sai. And it's a really great community. If you're interested in emulation at all, like you want to write an emulator or just kind of learn more about them, it's a really great community. Please join us. Check it out. You can also check out my YouTube channel, just as A Weigel on YouTube. It'll have all these streams. It's got the first like 8 or 9 of them up already, and I'm going to upload the rest this weekend, as well as finally actually pushing this to my GitHub, which is github.com/aweigel. and you can take a look at this code. I'm still planning to do like a retrospective stream sometime this weekend. Probably it'll be in the evening tomorrow. Thank you, Diana. Hopefully it'll be in the evening tomorrow, and I'm just going to kind of go through and say, like, look, this is why the code is the way it is. These are the design choices that I made. Here's the ones I liked. Here's the ones I didn't like. And kind of talk about what might come next, whether I'm going to finish this project or not. We'll see. We can kind of talk about that if you're interested. So yeah, that'll probably be in the evening Pacific time tomorrow. You can follow me on Twitter if you want. I'll definitely announce it there. And beyond that, just again, thank you so much for coming by and watching me work on this. It's a little bit of a bummer that it didn't quite make it to where I had originally intended to go, but you know, you win some, you lose some. No big deal. I had fun. And I really appreciate you stopping by. So have a great night, and hopefully I'll see some of you at least tomorrow.